Okay, great. So we have started the recording. I'm going to switch off my camera in order to have the bandwidth available for the voice and for interchanging the slides. Once we will dedicate some minutes to go to make the introduction of the subject itself. Okay. Okay, we are going to start right now. We have 11 people here. So first of all, welcome to the A2 subject. This is part of the first set of subject that we have in the master. So I hope you will be more than happy to receive these sessions in order to make or gain a little more knowledge about what is happening over there. Because things that most of the areas that you are going to study in the master are let's say technical, are areas that focus on the programming, on the definition of algorithms and so on. And probably this is one of the subjects that is the link on the master with the reality of the market, the reality of the things that are happening over there. So let me introduce briefly. I have been a student in the UPM years ago, as you could see here, and I have spent more of my life, professional life, working in Accenture, dedicated specifically on technical matters and innovation matters. One of the innovation that I launched in Accenture years ago, this is around 2016, 2017, was the quantum computing practice. A part of that moment, I was in love. I fall in love with the quantum computing, and specifically with the area related with development of architecture and development of solutions. And I dedicate a part of sharing the time in my life in Accenture with obviously my responsibilities as leader of software practice with everything that sounds with quantum around. That is, I was part of the strategic advisory board of the European community. I helped on the launching of the Quantum Industry Consortium. I have been part of the Quantum Technology Innovation as advisor for MET. MET is an organization, a Spanish organization that is aggregating everyone that is in the industry, let's say. I have been quantum advisor for one of the big four firms at the global level. I'm lecturer, typical lecturer in many courses and masters in a university like this one or business schools. And last year I have been quantum advisor for the Spanish government. Okay, so my last years has been full of quantum in my professional life. And in fact, I'm retired from Accenture, but I'm active on these areas on quantum and only accept jobs or accept work related with quantum. Okay, so let's move ahead. The first question you need to solve today, and this is important for you, I guess, is how to pass the E2 exam, because we are not have the typical exam with questions and so on. The idea here is to prepare a show work that you will make in groups, in work group 4, 5, 6 people maximum. You will need to select a topic, a theme that you would like to develop. You will have to find and capture information from different sources, or even reading papers or videos, whatever you prefer, and organize and prepare the documentation to be shown on an exam. So the exam itself is the presentation of the material you have prepared in group. Obviously, you have to have all of you the possibility to participate as a teammate on the development of that, and obviously the presentation of that. The length of the work is not huge. It's 10, 15, maximum 20 slides. You will have a fixed time frame for making the presentation. This is around 20 minutes. And as I said before, I hope that everyone in the team will have their glory minutes in the presentation. And we are taking, or I will take into account, not only the intervention of the team member itself, it's the distribution of work. I remember a team 2 years ago where the first team member, and the team was 3 people only, the first 3 member took 3/4 of the time, of the 20 minutes. And say, my God, this is not balanced. This is not fair for the rest of the people, because the people have interesting things to explain, but the people start talking with no control. That is something that we need to prevent, and this will be taken into account for the final grade of every team member. Okay, what's about At the end of that presentation, you will receive questions from the audience or your colleagues, your other people, the people of the other teams, and obviously from myself. What are the themes, the potential themes I invite you to evaluate for decide one of that? Okay, it's up to you, but I could propose to you some as a clue. Topics related with quantum ethics or quantum workforce challenge or quantum for AI or quantum in one determinate. What is the landscape of quantum in Latin America? Or what is the landscape of quantum in Israel? Or what's going on the industry of fully transplantation related with quantum? Obviously, I'm not interested in the rest of topics. Or if you want to dedicate the time to analyze the situation or the evolution or the roadmap of one determinate private entity or company. I remember years ago, some of your colleagues, I prefer not to repeat topics, obviously, but I put this like, like a notice. But I remember people that represent Pascal, a French company, or IBM years ago, or people that present India landscape last year, for instance. So the idea here is that you will have the opportunity to find and to explore the source of information, to organize that in a proper way, and to present and explain to your colleagues. And what happens if those themes is not the preferred for you? I have here family of themes. Just only choose one. Talking about situation of regions or countries, or industrial or regional or companies analysis. This is, for instance, a list of companies that I invite you to include there. You will see now here Pascal or IBM that has been traded before. Obviously, the situation year by year of many of these companies are changing, but I prefer not repeat the topics. For instance, on company analysis, what do you need to include inside? A strategy, plan, situation, on number of employees, the investment they are doing, the approaches, the topics on the products they are delivering, collaboration with other startup, milestone, SWOT analysis, this type of stuff. Or other topics related with not specifically any area, but could be an enormous landscape to select one. That could be ethics, workforce, or one determinate package of software, or forecasting of the situation of quantum technologies in general, or quantum computer, whatever you prefer. Standardization, trends, whatever you prefer. So just only, if you don't want any of those, and talk with your teammates and select one and propose to me. If it is sounds feasible for me, I will answer, okay, go ahead, start working, and I will wait all of you to be present on the exam on the 31st of this month, okay? And taking into account the people that are preferably working on their own region and so on, I will offer you to have two different sessions. One in the morning, CAT, let's say in the morning of Europe, and one in the afternoon like this one. Some people from Americas would prefer to have this session because it's a more affordable time frame for them. But it's up to you anyway. Okay. What's about the exam? The exam day, as remember, 10, 15, 20 slides maximum, 20 minutes. Everyone has to have their time, and 5 to 10 minutes to questions. I will consider in the final grade the team organization, the quality of content, the style of presentation, the credentials, the contents themselves, obviously the written speed, clarity, the ability you have on the soft skills you have for presenting the things. Perfect. What are the next steps for you? Just only you have to identify your teammates. That is something that I'm going to present to all of you in a few minutes. Select a topic. That is the first thing that you have to, and just only send to me an email explaining, okay, we are the team number 4, and we have selected the landscape in Israel, for instance. Okay. Please don't not select just only one topic, because I remember one year when we had three teams trying to explain the same topics. That was the financial service situation, market situation. So please provide to me a couple of 3 topics, and this will run as a FIFO. The first one that will select one topic will block that for the rest of the people. This just only in order to ensure that in the exam we have a fair situation. Because, for instance, we will have several teams working on financial services landscape. The first team will have the difficult question. The second one, we have the simple answer from the previous team already selected. So this is a question of budget. And just asking you to start working, because you have only 20 days for making the work. It's not that hard work. It's distributed among different 5, 6 members in a team. It is quite easy. But this is more a question of orchestrate that and prepare the put in practice of this presentation, okay? And what are the teammates? Who are my teammates? Okay, I have organized this in regions. So the idea is everyone that is in one determined region thinking in Asia, central, that will be Europe, Africa, Middle East, and so on, and Americas, will have their teammates in the same region for just only for logistic, will make easier the connection, the discussion in the same time frame, and so on. Once say that, in some cases we have not, let's say, a critical mass in one determined region. So I close people from two regions that are beside. For instance, in some cases, Asians will be with Europeans, or maybe in some potential cases, European will have the same team that the people that is from America. But the idea here is to distribute in this way. So please do a look on that. These materials are going to be uploaded to Moodle. So you will not need to take a lot of notes of the topics we are discussing, because at the end of this session, everything will be recorded in one hand and in the other. I will upload the materials in Moodle for your usage. Obviously, the whole view of the 100 of the slides you will have will be converted to PDF file, because in PowerPoint this will take hundreds of megabytes. So I will try to make this simple for you. So this is the team one. Sachin, Oscar, Jose Maria, Eva, and Vincent. The team two, Siad, Ismael, Daniel, Juan. Let me move this because it's impossible to read with this. And Daniel. Team number three is Alejandro, Martin, Alexei, Laura, and Gregor. The number four is Alejandro, Ignacio, Juan, Gaspar, and Sergio. Number five is Eduardo, Nurak, Usama, and Juan Ramon. And finally, team number six, Ismael, Marta, Julius, Kelo, Pablo, and Raul. The team number six is the people that live in or are resident in Americas in general, and the States, Mexico, etc. Okay. Have I forgot anyone? Because I have not the last list of attendance on this master, because we are one of the first subjects. In many cases, we have discovered that there are people that has not been listed in these 6 teams. It's so, please contact me by mail saying, okay, my name is, I'm inventing, Andrew, and I have not in the list of teammates you have present, and I will join one of the teammates. If, for instance, we have 6 people in the same region, I will create a new team and I will send you back in hours answering who will be your teammates. And for ending that, what's the way to put in contact with the people that are here in the same slide than me? Okay, don't worry. At the end of this session, I will send an email for every team, putting in copy the emails of any of you, in order to not distribute your emails for the rest of the people, just only for the people you need to work with. Okay. So more important for me, if any of you have not been seen or have you not seen in this list, let me know, and I will try to include in one of these. Okay, questions so far? I think was simple. This part was the simplest one. Okay, let's move on to the first part. First is to explain that we are going to take or to have a quite high speed in the presentation of the topics. Don't take these like topics that you have to study in detail. It's more important for me, it's more important for general purpose of this master, that you have a general idea of things that are happening right now over there. And the materials I'm going to upload that are quite massive. Things that for today we have around 650 slides. The idea is not to show to you all the 650 slides. It's just only to show the materials and to provide to you all the reference of that. For in the case you will need to continue with the analysis of one determined topic, if you have curiosity, if you need in your professional life, on your personal life, information related with any of these topics, go on deep on these materials and use the materials like a small reference for going in deep if you need go on more detailed materials. If you need more related with those topics, I obviously have more topics and more information for each topic. The question here is not to bombing you and to create the Bible for you, but a good set of materials as much updated as possible that could serve you as a reference of the thing that you have to have in mind related with the situation of the current status of the technologies, the quantum technologies in the market right now. And once say that, we are going to be just only focused on quantum computing. If we will take or we will decide to go on quantum sensor, quantum communication, quantum cryptography, we will need more hours for making so. So you will see in more detail some of the topics we are going to see here very, in a very quick way. So don't hesitate if you need more details or you have doubts to contact me separately, or just only put the question during the sessions at the end or when you have time. Let's move on. Okay, quantum technologies. Objectives that we have in this session. The first one is to provide you a basic introduction of the quantum technologies and challenges, understanding the geopolitical situation, understand a little bit what is the industrial situation and the industry that are more impacted with that, what are the typical use cases, and explain a little bit what are the trends and the way to implement one plan of quantum development in one determined company. And also to provide to you the vocabulary, to provide to you the insights, to maintain a conversation at the typical elevator pitch with anyone that will be interested in that. Because in the rest of the subject of this master, you will go in deep, in deep technical model. You will see what is the way to construct algorithms. You will see what are the what is the configuration of the algorithms, the way to access to machines, the way or the considerations for communication and cryptography, the basic consideration of communication and cryptography. But there are not any other subject that is focused on provide to you the overview of the situation in the market, in the world about quantum computing. So a part of this, you probably will have some messages and so on. Most of the people that are going to train you are in the market or in the university, so they have extensive knowledge. But if you need more detailed information related with the situation in the market or in the outside, let's say, contact me. This is the list of topics today, so we are going to start. Okay, why are we talking about quantum? Because quantum is hot, and quantum is in the mind of every people, and the promise of the quantum for making surprising things, of making enormous and marvelous things in the near future is huge, and that is included in a vocabulary a lot of different terms that probably you have heard, terms that you read a newspaper or a magazine. You will see once you have passed this master or that people doesn't understand anything related with quantum, but are topics that are today in the discussion every day. And don't forget that you are using quantum technology from a long time ago in your devices or on your day-to-day basis. But obviously that belongs to a previous generation of quantum. Related with that, the first quantum revolution of the first quantum generation is related with that, devices, lasers, transistors, all of that are using quantum physics. And they're taking advantage of quantum physics. But once you have controlled it and managed that, you have discovered that the things could be beyond or could go beyond. And it's when the second quantum revolution appears and we start talking about quantum computing, telecommunication, cryptography, sensing, not just only pure devices or pure effect that we discovered years ago. There are a lot of misconceptions related with quantum, and we are not going to review these in detail, but the people could imagine or could think that this is something immediate, that this is mature, that we are going to break the security in a couple of years. Nothing of that is real. We need to understand that the materials that we are managing today, the maturity of that are not high. And we are in the earliest stages of the evolution or the revolution of these technologies. So we need to be patient in one hand, and the other managing the quality or managing the maturity of those technologies with the level of the level of evolution we have in any moment. So taking advantage of the things could be made, understanding what is the future we have in front of us. Okay, these are materials that you will read with time at home. You have time or you have interest. And what is the real promises of the quantum computing? And this is quite simple. Let me put this. What is that? Okay, at the end, we have two elements here. The needs of computing, okay? As much complex the problem is, higher computation needs, and this is related with complex problems that we have today, and the size of the problem itself. So this area here is, this area here is the gain we are promising in the quantum computing. The state of technology, as I said, is not totally mature. We consider that could be usable the sensors, for instance. This is the industry or the family of development that are more advanced. So we are going to start seeing sensor in our lives in the near future, not sensor as we understand today, advanced sensor. For instance, quantum sensors are able to substitute GPS in the positioning. In fact, the British Army has put a alternative to the GPS that are not going to use satellite positioning and so on anymore, just only quantum sensor. That means that you are protected against the typical attack of one enemy if they destroy the network of GPS satellites. So this is something that useful for many solutions, including the military. For instance, the communication are advancing quite well. The more promised and the less evolved today is the computation. And curiously, is the point that we are going to cover more in deep during this master. So we have tons of technologies. Last year, GPS, as I mentioned before, magnetic resonance, and we have discipline like cryptography, simulator, sensor, and quantum computer. These are the more promises, and that where everyone is investing or trying to capture the knowledge and capture the space, but probably still is mature. And what's about the industries in general terms? What are industries that are more interested in all these technologies? Just technologies in general terms, not just only computing. Cybersecurity, obviously, because the threat that you probably have heard before related with the possibility to break the RSA algorithms and so on, that this is related with the Shor algorithm. You are going to study probably Shor algorithms in the subject of algorithms. But for implementing real life Shor, we will see after, we will take years. Years means 8-10 years, but that is a threat, or is a big enough threat for forcing everyone to start working on the post-quantum cryptography algorithms. So imagine 10 years for the market is not a huge period of time. It's something that need to be taken into consideration, and we need to take measures for evolve or for protect against that. So cybersecurity is the most hottest area today because the post-quantum cryptography, the RSA breaker, etc., etc. Next is healthcare or financials. It will depend on who you are talking with. For instance, most of my clients came from financial services, finance banks. But it is true that most of the pharma companies or healthcare companies are delivering today solutions that are not perfect, but are good enough for being implemented using simulators or using quantum computing. So those markets are quite. What are the next? Everything related with government and national security, the military forces, security forces, and then logistics. Why logistics? Because they have enormous possibilities to improve distribution networks and improve, everything related with the transportation and so on. And the rest will depend, energy, manufacturing, etc., etc. But we will see that in detail on Thursday. These are the reality. Today, the machine that we are, the quantum machine is the right one. The left one is the machine that we have in the 50s. But the reality is the level of development of both of them are similar. So the current computers are similar in evolution to the ENIAC we have in the 50s. Okay, related with the evolution itself, we discovered that till the 2019 we obtained the quantum advantage, let's say, and we have started with the NISQ area. NISQ is, we will see after, is noisy intermediate environment where we have to take advantage of the machines that, even in the case that they are creating a lot of noise, they are not perfect, are able to construct for some solution that will be, let's say, feasible or could be interesting for the market. And this is the nirvana. In one determined in the future, no one knows where or when, we will discover the possibility to construct fault-tolerant machines that will provide to us the security and the results and the execution of that. Okay, the niche area, the fault-tolerant, this is the area where we have, people say, and you will see here tons of different graphics, that we could consider that beyond 1,000 physical qubits, we will start the life in fault-tolerant environment. That is not true, in my opinion. Okay, this will need the insurance of the error rate and the decoherence in different, not just always a question of number of qubits. That's okay. This is a more, let's say, complex, more accurate way to define the situation. We are living here in the NISQ, okay? People are thinking on universal quantum computing, but reality is that we are trying to scale to large machines at the same time that people are creating or trying to find the fault tolerant. Obviously, this will be a step inch by inch to the machine will came where we'll have 1 million of qubits, physical qubits, and a good error rate and good decoherence to allow us to execute real big algorithms in the machines. So we are here. We are in that area. So we have a long journey to achieve the total operability of this technology. But it's a journey. We are starting about that. And in fact, in the last 2 years, we have lost attention. If you ask and you see the media a couple of years ago, quantum was everywhere. What's happening from that moment to now? The rise of the artificial intelligence, generative artificial intelligence. What's happening there? They are captured and they are attract most of the interest. So this is the typical graph where chat GPT, artificial intelligence is the good child, and you are leaving other child that this is close to be behind the water, and people that has been totally dead, that like the metaverse that 3 years ago was the king. Okay, that's the situation of the market. And today it is a reality regarding the investment. Most of the investment of the companies, government, and so on has moved to ChatGPT. What's happening? In the companies, we have seen that the number or the amount of money dedicated to quantum computing has been decreased, not disappeared, decreased. Governments have maintained the tension because obviously the strategic for them are more critical than for companies. Companies is more short, medium term. For governments, is medium, long term, and they need to ensure that in the geopolitical problems or geopolitical fight that we are living right now, they will be well positioned. So governments has maintained the rhythm of investment and even growing. The companies has decreased a little bit. And what's happening on that? This is a famous phrase of physics from the MIT that make a lot of a lot of noise. This is no longer a physics dream because they have solved their part. The quantum computing has are related with engineering problems that need to be solved because the physics demonstrated that this is feasible, that this is running, that this is possible. But today the situation is the engineer need to solve the rest of the problems, and today are there. And what's happening in the media? Even in the case artificial intelligence is everything, we continue having news related with the quantum in that say, quantum here, companies investing in quantum, countries investing in quantum, etc. I have not heard this recently, but sometimes ago I heard that the quantum computing was the fifth generation of computing. This is not true. This is not true because this is a totally new, different way to compute. It's not related in any way with the classical one. Even those we will see some comparison just only for helping in the comprehension of that, but they're not related at all with the classical computing. Obviously, for accelerating the classical computing, we have seen new strategies as computing, cloud computing, parallel HPC, GPUs, stack nanochips, etc., etc. But we are seeing right now even other alternatives like photonic, biological computing, any of them with promises and obviously with challenges, and obviously the computing. So we are not to be the evolution of the classical computing. It's a new branch, a totally new branch of computing. In fact, during the last year, 2023, you will see here some of the advances on some of the companies about the quantum computing, the integration, the level of integration, the appearing of the telecommunication companies in the landscape that has not made movement before, the evolution of the chips, just only for your reading. And obviously, we have topics or impacts that we expect sooner than later in the society, starting with security problems, the impacts on blockchain security as well, the improvement and the acceleration of the AI capabilities that today are more than remote, okay, etc., helping on discover new drugs or new materials, improving the analysis and forecasting of the weather, whatever that today are complex problems that are difficult to solve with the classical are candidates to be analyzed with quantum. And quantum is not something that we saw before that has absolutely new. This photo had more than 40 years, and this is the first, let's say, the born of the quantum computing. There was a physics computation conference hosted by IBM and the MIT in the States, and we have here some of the people that are created the market. In fact, Feynman was one of the EBTs there. Feynman, is one of the physicists that belongs to the Manhattan Project in the 40s, and he continues being focused and oriented to the quantum physics from that moment on, and that participated strongly in the definition of the quantum computing in the 1981, I think, this conference. This is a little history. So the history of the physics related with quantum computing. So the quantum physics is old. They started in the past century, the early of the past century with Max Planck. Remember that photo of the Solvay that was taken in 1927? What is the combination, the highest combination of Nobel Prize and the talent, or more talented photo that you see many? That's happening in 1927. Many of those people participated in the board, in the board of these technologies, but they are not the unique, because you could see have a Rodinger and Heisenberg board that worked on before the Second World War. After the Second World War, when everything was related with with atomic physics, as you know, the people continues they return to the quantum area. And Feynman studied the quantum electrodynamics, or the different people that participated on that. Till Feynman defined the quantum simulator in 1981. That continued obviously at the latest part of the last century and continue in this century as well. Okay. In the similarity of that, of the power of the number of transistor of every of these machine or milestone means, you could see here just only from 2018 with the first machine that was delivered at a scale, let's say, till the machine that we get delivered in 2020, that you have much more zeros in the power of computation measured in this case on transistors. So when we talk about quantum in general terms, what are the way to classify that? You will see many ways to classify, and depends on the authors. My favorite one is this one. I participated, as I say, in the European Community Static Advisory Board, and then I saw a quite, let's say, organized way to classify the things, and I love that, and because of that, I show it with all of you. So they divide the technologies in different areas. For instance, there are basic science that are supporting everything, and here we have communication, computing, simulation, and sensing and metrology. And this classification is quite good for me. A part of that, obviously, these four disciplines are crossed by other that are horizontal, that is engineering, software, theorems, and education, that are supported all of them by the basic science. And going one by one, what is the application of communication? Cryptography, sensor, clocks, architecture as well, a cloud. And what are the application of sensing? We have mentioned some of them: radars, sonars, substitution of the GPS, for instance, pressure sensors, or gravimeters. Why gravimeters? It is curious, but gravimeter is providing us a photo of the things that are beyond the surface, for instance, and are used by a part of the military forces for detecting submarines, or detecting other elements in the land. For instance, prospection of oil prospection analysis. This is something that most of the oil companies are interested on, and they are paying their own investment for creating those devices. For instance, quantum simulation, that is, for instance, for emulate the behavior of the nature in an electronic way, let's say, in order to avoid the very, very expensive experiments and making, prediction or more accurate prediction than the ones we are making today with the classical one. And obviously, the quantum computing application, that is the ones that will be the main focus for us. And related with basic science, what inside? Techniques for providing or allowing the construction of the different verticals, because we are having enabled technologies, manufacturing, the way the supply demand chain, the control elements of controlling software, basic software for everything, the basic theory, the basic science, and obviously everything related with education and training programs. That is one of the biggest, let's say, towers of most of the plans we see around the world. And for that, we have a description in more detail of the thing we have said before. Obviously, the more interesting for us will be quantum computing. And here we will go in deep or more deep in architectures and technologies that are behind. Okay, focus on quantum computing, the basis of that. These are phenomena, quantum phenomena that probably you are familiar with because you have read anything or something before. Superposition, the tunnel effect, entanglement, the statistics, results, etc., etc. The superposition, remember the Schrodinger cat, but at the end, if you want to represent that, it's like a coin switching on, and just only when you stop the coin, you will see the result. So this is A or B. That's so simple. What is the tunnel effect? The tunnel effect is something that we are using every day in annealing, for instance, because we are creating a physical environment where we are modifying the structure of the algorithms for being deployed in a machine that has connections among the different qubits. This is something that you will see in practice when you start making, adiabatic or annealing practices in this subject, where you will see that for constructing the Kubo function, you will need to turn or return or modify slightly the algorithm for being deployed in one determined machine that has a physical configuration, and you have to take into account the physical configuration. Once you have put your algorithm there, this is a physical machine. This is not digital. So they have the natural trend to go to the minimum energy status. As you have constructed your algorithm for trying to find a solution, that the solution has been aligned with the minimum energy situation, immediately once you have deployed that, the solution is immediately constructed by the system. And the answer is the minimum situation, the minimum energy point that is the direct effect of the tunneling that you are seeing here. So avoiding to move around the curve of the function, the tunnel effect goes from the point you have started the analysis to the minimum energy. If you identify the minimum energy point, when you resolve, you will obtain the solution of that. And this is something that you will study in the Google function. And what's about the entanglement? The entanglement is an strange effect because no one is able to explain why and to even represent that mathematically. But this is something that the physics, the experimental physics has demonstrated, even in the case the theoretical are not able to explain that this is effect, this is exists, this is real, and this is used. And we could represent that, for instance, in two coins working in parallel. We turn the two coins at the same time. We take one coin, we move the coin 10,000 kilometers far, and then we stop the coin I have here, and the same result will happen in the other coin 10,000 kilometers far. No one understands why, but it's happening. And in fact, this effect is allowing us the communication, the quantum communication, and part of the effects we have in a quantum computer. In fact, the entanglement is absolutely the basis for connecting and for creating the momentum. We will see one determinate gate, for instance, is named Hadamard, when you will state that, and you will see that at the starting of your algorithm, when you construct your algorithm, because Hadamard is creating entanglement among the different qubits, as well as they are creating the initialization moment for one determinate qubit. So you are putting everything at the initialized status, putting the qubit connected among them, you see the Hadamard gate. Even this entanglement has been analyzed in a microscope, and this is the image that we have seen. It's like a yin. It sounds funny. This is our friend. Once more, he appears here, and this is a quite funny guy. If you have the possibility, I'm sure that in a medium long term, someone defined it or decided to create a movie explaining the life of this guy. That was very, very funny. If you had the opportunity to see the movie, I would recommend, because it's, let's say, interesting. But this guy is very clever, say that anyone who claims to understand quantum theory is either lying or crazy. So those effects that have been demonstrated has not explanation, and this is anti-natural for us. It's not for our mind is the habit to think as the classical is waiting and everything is clear, everything is running, everything has explanation. In quantum, we have not explanation for everything. In fact, we have explanation for few things, but they are running, so they are real. So we could take advantage of that. So we could take advantage of that for making strange things, but valuable things. EA, communication, cryptography, computation, sensoring, etc., etc. Okay, let's move on because we are in delay. What's a qubit? It's something that is quite simple. The representation of a bit, is a switch on and off, 0 and 1. A qubit is represented by a Bloch sphere. What is Bloch sphere? The vector that is from the center of the sphere to any of the potential points in the surface of this sphere are the potential value of this qubit. That because the first principle of superposition, all the values could be visible at the same time. Just only when you are reading, you are seeing exactly where that superposition, what value that superposition of the qubit is providing to you. This is a little more complex than that. You will see more in detail in the next subject. Sorry. At the end, we are seeing some comparison, as I promised, among the classical and quantum. You see here in red the bad effect, and in green the good effect. For the byte, the unique weak point is the poor performance they have. You only have one possible state of the two up to n elements. That this is The opposite in quantum, you have two up to n possible states simultaneously, and this is the key. For the rest of the features, we are losing because we could not evaluate, we could not copy, this could not be erased. So this is probabilistic and not deterministic. So true execution could provide to you two values instead of the same one that you have always when you execute in classical. But once say that, they are not simple. They are not similar at all. Okay, we have many different gates that force movement inside the block sphere. It's like robotics. Take a turn at the right, 90 degrees, and then down 55 degrees. You are playing in a 3D element, not in a flat element, not in 2D dimensions that you are playing with classical. So this may complicated that. And in fact, you could construct your own gate with some movements. You have to understand why you need that gate. That is different history. But theoretically, you are able to construct and create pulses for the qubit for moving and create your own gates. This is feasible. Not practical, but it's feasible. And what are the big difference and what the value for the qubits? The same that we saw before. In classical, we have 10 qubits. That means one of the 1,000 possible states. In quantum, 10 qubits is 1,000 of the 1,000 possible states at the same time. Obviously, what is the value of that? Just only think, what happens if you are moving one machine from 10 qubits to 11? What is the effect of that? In a machine, in a normal machine, you will have just only the effect of having one more possible stage. In the case of a quantum, you are doubling the capacity of computation. That's something. So passing from 10 qubits to 11 qubits is doubling. Passing to 11 to 12 is doubling again. So when you see in many newspapers, okay, IBM has moved from 127 qubits to 433 qubits. This is the announcement of the last year. No, sorry, in the 2022 announcement. The announcement last year is moving to 1,000 qubits, the Condor one. That doesn't mean that you are multiplied by 3, the capacity. You're multiplied by 2, elevate to 433 less 127. This is the difference of power of the computation you have obtained. So it's massive, totally massive. In a one simple sample that you will see here, for instance, a machine of 50 qubits, okay, is the equivalent of a petabyte of space, just only for understanding. And that petabyte means every byte is the evaluation of one condition at the same time. You will have a question of 1 petabyte evaluates at the same time. That is massively growing. And the same in 64, you remember the typical chess problem where you could grow the number, and you put a grain in the first, double in the second. That means at the end, 2 up 64 means 1,645 times the production of weight of the word. So we are not talking about 64 qubits. We are talking about today, in Condor, 1,121 qubits. So it's 2 up to 1,121. So this is the power of evaluation. Nothing understandable with the size we are typically managing, because 280 qubits are this enormous name of evaluation in parallel, that is equivalent to the number of atoms of the universe. So you could not imagine the power of calculation we will have available for us. This is part of the promise, and because all the powers are fighting for having this machine first. This is more related with the same topic, the power of computation. And this is a joke, okay? Quantum, you put to Google quantum computers will, okay? This is a clear case of superposition. 2 different states are the same way. Okay, talking about gates, and this is something that you will study in more detail, absolutely more detail, not just subject. So this is just only a pure introduction. In many cases, when we talk about logical gates, when you have knowledge as engineer or computer science or telco science, etc., you will be familiar with the digital gates. Digital gates that were constructing digital approaches for constructing circuits, for solving, for instance, finite automata in typical physical problems. We have made the same approach. Remember that we have said that we have not very evolved on the quantum computing, let's say, construction of machines. So we are at the earliest stages. We are so close to the bits, the similarity of the 50s or the machines we have in the 50s on classical, that we make this comparison for just only helping on the comprehension. So where we construct a circuit using digital gates, we have equivalent on quantum gates. And in fact, these are the typical based on Boolean algebra, not, nor, and etc. And we have another set of operations with qubits, with 2 qubits typically, that are rotation, X rotation, Y rotation, set the X, Y, and Z gates, quantum gates. Superposition, the Hadamard, the initialization I mentioned before, etc., etc. At the end, many of that could be substituted by Zenov gates. Okay, but this is a different story. We are not going to in detail there. Every of these gates has a determinate movement inside the sphere, the block sphere. This is something that you will study when you go deep on gate computing. But this is just only a reference for you. We have a set of digital and we have a set of quantum gates. The unique gate that is equal is not. The other are totally different. And this is a cheat set that I provide to you as part of the documentation. We are not going to see that in detail. Just only think that for representation of the classical gate we use in Boolean, for the representation of the quantum gate we use matrix, because we are talking about multidimensional stage. Typically, the representation is matrix. And you go in deep, one of the big problems we have is to mobilize and to make operations with those matrices. When we talk about different qubits, you could imagine to merge enormous number of qubits, multiplying matrix when one dimension, another dimension is a nightmare. And it's very strong computation either for emulate or simulate that situation. Okay, and what's the way to go from the qubit? As we know, and we remember what is the way to go from the bits to the algorithms and to final program, the high-level programs. Here is quite similar because once you have described and you have defined the block sphere and the qubit and the gate, we play with something similar. The gate are combined for constructing quantum algorithms. This is the typical representation of IBM 5 qubits lines, that the typical representation and the connection among one qubit with another qubit using one Hadamard. Remember that the H is the Hadamard and the connection of different gates for making operation. And this is the oracle, is the last gate that you always put here because it's the one that provide you as a result. They are asking the result of the situation of one determinate qubit, and at the same time they are destroying the status. So you will have the result, but that will not be copied so far. And these quantum algorithms are representing the high-level programming using high-level programming. In this case, is Python. And in fact, Python is the language you are going to use from now on for making your practice. And you will see in most of the commercial and not commercial, even the university environments. Okay, we will talk about languages after on. And this is the aspect of what determinates algorithms. You have here the different qubits, the different gates, as I said, and the oracle ones, the measurement. And you have here representation of different algorithms. You will see those in details. In fact, I think you have a subject for talking about this Koska schematic circuit, this Koska in detail. This is one of the big algorithms available for us. Obviously, many of these, this is a more complex algorithms, is converted in this high-level language, but it is language, if someone with experience in one determinate program, for instance, or in language, in Python, for instance, will read your program constructed for representing the circuit. They say, this is, who programmed that? It's a new joiner for sure, or they didn't understand anything related with Python. We are not taking Python at all the power. We are using Python opportunistically just only for representing in a high-level language the things that we need to explain to a computer, a compiler, for make the algorithms that for us is at the end a circuit. So this is not a perfect Python program. It's just only a Python, like a vehicle for making the representation of translate that instructions, high-level instruction, to a machine, okay, that will represent that in a circuit. At the end, the thing that are going to be executed is a circuit. Okay, and there are some lines that, for instance, we could not copy data, for instance, where we have linear algebra, the breakpoint, beginning point, so some rules that you will see when you start studying about programming. Quantum versus classical, we have introduced that. There are something that is absolutely different in a computer, a classical computer. Even in the comparison, you only could play quantum versus HPC, high performance computer. You could not compare with a normal machine because this is not fair, let's say. So in many cases, you will see the behavior in an HPC against a quantum computer. Or for instance, or even the evolution from classical to quantum. And this is the typical classical environment that we see. In the emulated environment, the NISQ, that is closer, for instance, for annealing, and the pure quantum, and the evolution from classical and quantum. More close to quantum, more different than the ones you have in classical. But don't forget that we are taking advantage today to make simulation, or for instance, simulation of annealer, or simulation of gate-oriented using classical. Or, for instance, methods that are inspired in quantum, but they are executed in classical. For instance, things constructed in tensor networks that are really classical, classically constructed, but they are inspired in the way that quantum computers are making the things. That means that they are trying to take the best of quantum for being executed in classical. And in fact, there are companies that they are delivering solutions that they are saying that this is classical inspired, that are based on tensor networks and are running today for solving real problems in the industry. Okay? Companies like, for instance, Multiverse in Spain or Zapata AI in America. And this is a paradox because in the classical world, in the classical computing, the majority of the things that we see are software. And this is the opposite here. We are continuously talking about hardware. Why? Because the hardware is so immature that most of the investment, because they are trying to gain the situation in the market, are focused on trying to solve the real problem we have in the hardware. And that advantage will appear once we have that machine running. This is a comparison of the performance on classical and quantum of different algorithms. You will see clearly in classical, everything is going up immediately. In quantum, we could play with a more arithmetical situation, except some problems of optimization, because you could not execute everything in a quantum computer. In fact, the quantum computer, for executing and take advantage of that, you need to select what type of problem need to be executed. Okay, more comparisons. And we achieved the point of quantum supremacy. And this is something that Google launched to market. We have obtained the quantum supremacy. Remember that the quantum supremacy was obtained in 2019 just only for any specific problems, and specific problems in a very controlled situation. But that make a lot of noise. Quantum has arrived. And this was not true. It was just a marketing operation. But from that moment to now, we have lived the competition and the race of obtaining one algorithm, obtaining one situation where the quantum computer will win any combination of classical. And we have seen this about the supremacy history. You see the starting point, China, the state, China, the state, China, the states, the competition, and we will see after are related with the competition in the geopolitical as well. Everyone wants to position themselves on the supremacy position for maintaining and constructing those systems. But they are real situation, they are real analysis of what that supremacy could mean. That is the situation, the typical factorization problem where RSA, let's say all the communications and the security are based today. For instance, a typical machine took 75 years for breaking a 63-bit key. Obviously, a quantum computer will take seconds. The solution for that in a classical computer is just only grow the number of bits of the RSA. That is, instead of 63 is 2048. Perfect. But a quantum computer is not material. We just only take 100 seconds. They are not taking billions of years. These are the power of computation in parallel that the quantum computers are promising. Because there are algorithms that is probably one of the first algorithms delivered in the academia related with factoring or breakage of factoring. So doesn't matter the size of the key you are using. That they will be able to make this in a finite time. But for making this a reality, we need time. Don't worry that. But not just only talking things that are related with the security. For instance, one of the more complex problems is to find the temperature of a superconductor ROM, the fabrication of the chips and so on. That is impossible to calculate in a classical way in a machine, in a quantum machine, takes minutes. Okay? Or representation of molecules. These are many, many typical problems. This is the typical problem of the roots. In only 16 stops, you will have more than 20 billions of possible routes. Typically, this is the problem that is growing fast and fast in a classical that has no solution in most of cases. There are some, bypasses to obtain a good solution, not evaluating all the possibilities. And that's very good for quantum because quantum is able to evaluate in parallel with real brute force all the solution and provide to you the best one. But not just only that. For instance, for represent the nature. Remember, that's one of the topics when we talk about simulation. It's impossible to calculate the need for represent a molecular. And this is something that for a quantum, because the word is quantum, is feasible with a small number of elements. For instance, the penicillin molecule will take 10 up to 86 transistor equivalent, impossible for a computer. But this is possible with a quantum computer. Related with the time needed for break with the short algorithms, the RSA security. Best approaches are talking about millions of physical qubits, and we are not close to millions of physical qubits. The biggest machine published is around 1,000 qubits. So we will take years for achieving that number of qubits available. That's the time that most of the companies or government has for update their algorithms in order to defend themselves against the quantum computer. So in many cases, they are talking about quantum advantage instead of quantum supremacy. more analysis related with the power of computation. Let's move fast. So when we talk about a more modern author talking about supremacy, not just only the question of breaking the RSA, of obtaining supremacy, they are talking about different things. Obviously, the typical one are related with the complex problems, things that are impossible or very difficult to obtain with classical, and the quantum could make. But this is a small size of the total problem we have in nature solution, not the accurate solution or the best or the unique best solution. I'm talking about the time needed for obtaining a solution. Remember the number of seconds the quantum need for breaking RSA. This is a much faster solution than the ones we have with a classical. In the case the classical could achieve a solution. There are other approaches talking about supremacy when you, even in the case you are not solutioning anything new, you are obtaining something useful with that power of computation we have. Even in the case you are not obtaining the best solution, but you are obtaining something useful. This is very typical in the niche environment. Another, and this is in mode today because the effect of the of the sustainability is the energy cost and waste of that computation. Because obviously this appears when you are trying to train, for instance, AI models. The AI models are consuming an enormous amount of kilobytes or megabytes, megawatts, sorry, talking about power, and a machine for making the calculation of that. If you could make something similar in a scale with a fraction of this consumed, you are more efficient. So that is another point that most of the modern authors are talking about the supremacy of the quantum computing. But where today? The traditional is growing, not growing using the Moore's law because we are taking other bypasses, like for instance, parallel processing, GPUs, etc., etc. But the power of the niche cases of the quantum are promising this performance. And obviously, when we have a general quantum use cases, a general quantum hardware available for making these, the growth will be fast. But where are today? Today are here, very close to obtain the supremacy of the, let's say, not supremacy, the advantage in some algorithms, in some specific cases, not in all the cases. So we have very close to break that, let's say, anathema. The point is, how much time do we need to obtain advantage in the general purpose machine, in the general hardware? And this is the good incognito. We could not predict when it's going to happen that. And in fact, today we have in the classical world, and we start moving in the verdant flames of the niche. Just only when we achieve the fortress of the fault tolerance, we will have something that will be really providing results at the scale we are pursuing. And in fact, these are the regression line that the evolution of the machines of IBM had some years ago. And they say, okay, in 2023, when they have delivered the machine of 1,000 qubits, we expect a growing in the capacity of the machine. But this is not happening at the same speed. Even IBM has gone a step back and had changed the architecture because they have discovered that the evolution of the physical hardware is not able to grow as fast as we know. Why? We will show after that, but it's based on the engineering problems that we mentioned before. And the best answer is we have not yet discovered the quantum transistor. So we are playing with the bulbs that we have in the 40s. This is the level of evolution of the technology so far. Till we will discover the transistor, the jump that we expected will not happen. And in fact, quantum has lost part of the attention in benefit of AI, as we mentioned before. And in some cases, people are starting talking about the quantum return. We will talk about the quantum return next Thursday. And in general terms, what are the challenges we have in quantum computing? The things that we have already mentioned. Okay, it is difficult to create scalable machines, physical hardware machines. We have a lot of noise, errors. We have not the all kind of algorithms. We have very few number of algorithms. The error correction and error mitigation is very new. Is very poor. We could not implement real networks of communication because there's an evolution as well. Something that will generate for every environment. Skilled professional, lack of skilled professional. You are here in the master because you are aware of that and you want to be in the good wave in the next years. There are problems of the integration, and this is important because the quantum computing is not going to be alone in the machine. It's not the unit machine of the future. This will be condemned to be connected with the classical one. And today, a quantum machine is working like a special mathematical processor, external mathematical processor for a classical machine. So only some algorithms are going to be executed in the quantum. The rest will happen in the classical. we have not a specific programming language. We are destroying the sense of a Python compiler for using that like a vehicle, as I mentioned before. We have not a standardization, and this is not cost effective today, the computers we have. So we are even in the, in the manual definition. Every machine are not industrialized. It's different than the others. So it's something that the lack of standardization and the lack of industrialization is creating for us. It's not a cost. It's not cost effective. Talking about taxonomy, there are people with a lot of time in this case, the ADCs and an analyst that has created a first taxonomy of the services, products, etc., related with quantum. I'm talking about platforms, services, systems, investment, etc. They have created here categories just only for understanding what is happening, what things need to be taken into account inside. For instance, in services, the platform itself, IaaS, quantum computing, IaaS, PaaS, and SaaS, similar to cloud, the classical cloud, and services, development services, deployment services, fabrication services. It's just only an ontology. It's a curiosity, but it's interesting. You need to go on deep on that. So I have included in the materials today. This is a more level of detail, a higher level of detail when you see here the definition and even some of the examples of the constructor of every of these environments. This could be probably more interesting in the supply chain in the same way from the components, the physical components to the industry. We have several typical quantum system, quantum computing, communication, and sensing. And we break these in elements, still go to the fabrication of the producers of some of these elements. If you need to construct a machine, a hardware machine, you will need to take conducting, you will take this line. If you take, for instance, diamonds, so you will take this other line. That's only, it's a classification. And this is a first picture of the people that are involved on this market. And this is not exhaustive. So we will find here people that has not been represented. So when we talk about the hardware, that is one of the biggest problems and the biggest challenge, because we have not a powerful hardware, we are not able to go faster in the evolution of this market. This is familiar for you because we have talked about before. These are the situation today. Running in classical computers, quantum inspired, and that's all the companies that are playing in this game. Multiverse and Zapata and quantum inspired emulators. Many of the providers of the hardware has their own emulators, hardware or software if needed in their machines. And then we move to the quantum machines. The analog, the basically is the adiabatic. The big constructor here is the Wave. There is another company in Spain that is playing in analog. That this is Kilimanjaro, based in Barcelona. There are other experiences in Japan, Fujitsu and Hitachi. I think they have constructed their own annealers. But imagine annealer has a short history in front of them because obviously the future is gate-based. It is general purpose. This is for specific cases, specifically optimization problems. So you could solve the optimization here and here, but you could not play other algorithms than optimization here, for instance. Optimization is open to many usages after that, but is not universal. Even in those, D-Wave has launched a specific line, being the main vendors of analog. They have launched the construction of gate-oriented machines inside the Wave. So the Wave has today two lines, the analog line and the digital quantum computing on the other side. Both of them based on superconducting. That this is one of the techniques of the kind of technology you could use for that. Most of them are playing in ISK, others are trying to explore the full tolerance. For instance, C-Quantum, that is working for the American government, for armies and so on, they have received an injection, massive injection, more than $800 million for the investment, are focused on that. So they are perceived like the future of the gate-based machines. But they have to demonstrate that they are able to construct that today, that this is not so clear. Okay. Okay, so we have several type of machine, different type of evolution. So not all the technologies are at the same level of evolution, and this is something that you will discover in a few seconds. Because this is the typical configuration of a quantum machine, a hardware. You have here the computer, the classical computer, the qubits, the controls, the electronic that is controlling the devices that are from this point to this line, that this is vacuum pumps, where you will see tons of photographies. The big truck here, the big trick is the compressor. This is the machine that is creating the frigo environment needed for the vacuum and the execution in the typical quantum chip that is in the lowest level. Remember that today the computers are running close to the absolute zero. But this is something that are forcing the current configuration, the current hardware, to have an extremely powerful vacuum and compressor for creating the temperature needed for the execution of that. This is a general configuration. We have another big problem, that's the tyranny of the wires. One of the problems that the engineering is trying to solve, it is impossible to put more wires in the same component, because you have the chip, and I have, imagine, 400 qubits inside, and I need to connect many of these qubits, and these need to be made using, in some extension, wires for sending the signal to the qubit for operate. And we have a problem. We, in many cases, could not put more wires inside. Okay, we have here, for instance, the typical, the different technologies, cool atom, trapet, superconductor, etc. And you have here challenges like a DAFO with the different highlight challenges, problem for scalability of the different technologies. Okay, so this is quite intensive. I'm going to move this faster to continue with the presentation because, wow, we are in a strong delay, I'm afraid. And we have here a summary of the pros and cons of the platform. Okay, who are the constructor of every of these machines? And this you will see summarized in every of these machines, who are the main companies they are playing with. For instance, in Anila, as I said, the Wave, Kilimanjaro, and the Japan. What is the money that has been moved, and how many machines there are in any country? In the US, is the biggest with China in number of machines. Many others, typical suspicious, are involved in the same, and the distribution of those machines. So what type of computing we have? And in fact, these are the two lines of working you are going to see in this master. Quantum annealing, they have real machines where you could deploy and execute algorithms, and gate machines. And the first adiabatic is using the tunnel effect, and the other gate model are using the approach we showed to you about the qubit, the gates, the combination, the circuit that we have mentioned. Okay, related with simulation, there are a lot of confusion about that, because we have gate hardware, annealers hardware, and we have in some cases annealers that are constructed by software. This is a simulator of one annealer, and this is the typical simulator that many universities have created are software-based. They are emulating the behavior of the tunnel effect, executing, let's say, in this case, the whole algorithm. That this is the tunnel effect we have mentioned, and this is the comparison or the configuration and the consumption of energy of one emulator that are following all the curve, the function you have included inside the machines, compare it with the consumption of energy of a quantum annealer that really is moving using the tunnel effect from one situation to another. The time consumed and the energy consumed are absolutely different. In fact, for that simulation, there is let's say, a good barrier, that is the number of qubits that you could emulate. Just only very few machines you are able to surpass the 53, the number of qubits simulated more than 53. In fact, there are very few machines. Here, this is a Chinese analyst that's including making an analysis of the situation year by year. I have just included what are the advances of any of these techniques. Okay. And the advances of the different companies working on those machines. So those material will be provided to you, so you will read it. You are curious of that. And obviously, what are the roadmaps of the evolution of the different techniques? Superconducting, neutral atoms, semiconductors. What is the expectation we have in the different evolution that could be help you to take a, let's say, decision related with what are the favorite technology you will have? And here's a photo of what are the money put on the different technologies. You could see that superconducting is the favorite today, specifically because it is technology that we are managing during a lot of years. It's the basis of the classical and is well known for the bigger constructors. So they have decided to take the same decisions on the configuration, of physical configuration of the machines, because that technology is well known and implemented in their fabrication processes. So IBM, for instance, is the biggest investor here with 2.3 billion. Suggested or calculated, because they are not explained that they have invested that. This is approximate that date. And in Intrepid Ions, you have Quantum IonQ. Photon is the biggest capture of money here, because it's the big promise. Let's say if they are able to deliver something. And in the same way, they could be more, let's say, more aligned cases for specific machines. Depends on the nature, physical nature. But okay, this is changing every day. When the machine is evolved, suddenly this is put in dark green or the opposite. Another point that is interesting, the cheapest one is the trapped ions, okay? But as you know, most of the people are working here because of the technology well known and manageable, instead of the other that are in the pure analysis on them. This is something quite extensive. We are not going to be in detail, just only explaining to you that there are stacks where they find the different layers or the different elements that we need to manage for constructing an architecture. And there is a long list of providers on the different layers, application, algorithms, framework, etc., etc. You will have all this material. It is not something that you need to know in detail. There's only to have available. Okay, related with algorithms. There are families of algorithms. In fact, when you construct a new algorithm, you will try to find a similar one. Okay, this is a problem that could be solved in a for instance, in a K-quasi cycle or in a graph, okay, that will help you to identify what are the typical base algorithm to use and to modify to solve the problem. And you have for adiabatic, for annealing, for the machines, the way, for instance, or you have for gate-oriented, that you have, in many cases, equivalence. For instance, the QA is the equivalent to the optimization problem that you have in a QCT there. So here you could solve basically optimization problems. And you have just only one algorithm in gate-oriented that is solving the optimization. And because of that, I say that the gate-oriented machines, more universal, are the future for this. Classification. I have put this a list of algorithms. If you want to go in deep, just only push this and you will find, or just only using the reference to find more details about algorithms. Obviously, these are more or less aligned with the different machines that we have mentioned. And you will have algorithms and description of the algorithms in many papers. There's only some reference here. Some of these algorithms could be used in the NISC, let's say, era. Others need to wait till we will have more accurate machines, for instance, full tolerant machines. But optimization, in general terms, could run in NISC without any problems, or RSA breakers and so on. Grover or Short, the two big algorithms that all of you will hear about, need more power of the computation for making this. And there are algorithms that today are making the work, that this is the typical optimization problems, and the purebred, that is the work, that is the RSA that we will have in the next generation of algorithms in hardware machines that will grow exponentially the power of these algorithms for real solutions. What are today the more, let's say, useful? Machine learning and optimization. Simulation and modeling, okay, but these two, specifically the movement of optimization for taking advantage of improving the results on the machine learning, is one of the biggest area of investment. There are a ton of papers today talking about that. Okay, and this is a simulation or a comparison about the classical and the quantum, the computation of classical and quantum in comparing on different, let's say, features. The programming framework, the compiler, the virtual machine, etc. This is interesting for just only for hearing that. And the major advances in algorithms during the last year in different providers. Okay, architecture. This is my opinion, personal opinion. Part of what is going to happen here. The architecture will be absolutely key for making a success this evolution. And it's in different lines, because we have a lot of challenges that we need to solve that could be not totally solved, but at least partially solved using algorithms, and other problems that could be, prevented. These are the things that we need. These are the explanation of why we need an architecture. And in fact, there are, for instance, companies in this case, Zapara, that are explaining that there are obstacles for the creation of that, but there are big opportunities for this architecture as well. These are the things that we need to solve the challenges of that. Lack of standardization, coexisting on the different quantum computing paradigms. One of the things that the quantum computer architecture need to solve is the possibility to solve a problem, a real problem, combining the different machines, because I could find a machine that could be more feasible for optimization and another for other kind of problem. If my big problem could be decomposed in different parts and every part could be executed in different machine, at my decision, they will have a good advantage. And that means that every vendor, every constructor of hardware, just only are taking into account their own hardware. And they are saying that they are able to solve everything. That is not true. So just only dependent third-party architecture will be able to connect different hardwares. No one of the vendor will be interested to provide a possibility to connect with the competitor. So that will not be provided by them. This needs to be provided by the architecture constructed inside the organization, inside the HPC center, this type of stuff. Okay. The architecture at the end need to be scalable, flexible, compatible with other architecture, classical architecture, because they have to connect with, support interactions, manage the data. Remember that one of the big barriers of the quantum machines has not memory. So everything related with the management of data, the persistence of data, the storing of the results need to be made in the classical, but not in a pure classical. Need to be made inside an architecture that integrate hybridize the classical and the quantum environment. So in the typical stuff of architecture, you will see tons of different models. This is the architecture, for instance, a classical architecture of Oracle, digital architecture. Obviously, the integration needs to connect with the system of records, the classical mainframes or the classical legacy, and obviously the quantum ecosystem. This is an architecture from NVIDIA. We have tons. Everyone is constructing. This is one of the best, in my opinion. IBM has a quite long history in all the classical world. So they have the view of maintaining the connectivity and the connection with the classical and quantum. the architecture needs to be defined in two different lines: execution architecture and development architecture. For every of those, they have abstraction layer. This is a photo of the first architecture I created in 2017, but the main areas that are represented here are the ones you will see in the model architecture as well. The control layer, the orchestrator of the APIs for connecting to multiple backends. You will not see this approach in one vendor, in IBM, in Rigetti. No, you will have just only IBM. The other doesn't exist. They only want to use, or the only one that you use their own infrastructure, not other. Obviously, for a agnostic constructor of architecture, we need to guarantee that we have a level that is able to manage the flow using different access to different hardware machines. And this is the approach that we constructed and connected with gate-oriented. Obviously, the steps that I have the architecture inside are different, depends on the nature of the machine you are going to work. But the real part are here, when you have the input, output, the orchestration, the data storage, and the connection with the different and expertise. The architecture probably is the more sophisticated area of the software development. And in the development architecture, something similar, obviously. That has been, this was the definition we did on 2017. Obviously, the evolution of the different vendor has oversized this, and everyone has their own development architecture that is represented, for instance, in this graph. So this is something that has been analyzed and developed on the different vendors. And in fact, there are vendors like, for instance, Classic, that is thinking beyond. Okay, what will be the development architecture I will wants to have? Okay, this is the real situation. Everything is manual, but theoretically, the environment of the development will need to be in this way, defining the problem, and the rest will be automatic. This is a dream today. And these are the different vendors with the different levels, okay? The libraries, the generic libraries, the machine, etc., etc. And related with programming languages, something similar. We have tons of them. What are the more popular? Okay, what's happening here? What is the more popular? Today, these are the distribution. The more popular you see here are Qiskit. This is one of the machines you are going to play with during this master. The practice on gate-oriented, I think you will make that in this. Okay, and this is a reference on multiple languages, just only for your reference. And what's about the compiling process? Because you are constructing an algorithm, this needs to be compiled. And we could talk about transpiler as well, but this is a different history. The compilation process is creating and taking the code you are constructing in a high-level language like, for instance, Python, and convert it in machine, and convert internally in another compilation process, impulses to the different qubits. It's similar, it's very similar to the compilation process that we have in Classical. This is, for instance, the structure of the compilation process Anyway, we have strong challenges in the compilation process because we have not so evolved that technology, that middleware, that the ones we have in Classical. And related with engineering tools, something similar. This is the transpiler I have mentioned before. This is an internal important piece because the transpiler is able to take an algorithms and structure the circuit and the pulses they are going to construct depending on the machine, the physical machine they are going to be executed. Because as I said, we are not in the industrialized phases of construction quantum machines. Every quantum machine is different. So in the quantum machine number 1, the qubit number 4 is damaged. So we need to avoid the number 4, and the compiler is working in a flat way. The transpiler is converting the algorithm and the pulses they are saying in order to avoid the damaged qubit. So they are constructing an equivalent let's say, circuit, avoiding the usage of the qubit number 4. Because of that, transpiler is a middleware very important in our life in the NISC environment because they are ensuring that we are adapting without any manual intervention, theoretically, the algorithms for the physical machine and a specific physical machine. Okay, there are a lot of, this is the appearance that middleware has in IBM, something that you will be familiar with very soon. And what are the advances of this in the different vendors? And not only that, because we are talking about full stack, and you have the big vendors, IBM, DY, Rigetti, they have more or less full stack in the different lines. That's something to take into account. This is the photo for the different vision of views of the architecture of IBM. But we have our own architecture. So just only, if you need to construct or to work with one determined one, just only select which one and see the configuration and the components that you need to manage. And there are other, let's say, agnostic, depending on the vendor, that are part of the typical layers that has one vendor architecture, are including the others that we mentioned before, the possibility to connect in multiple type of paradigms, okay, or different vendors. That is something that not all the constructors typically make. For instance, one qubit, that is also a company that is making compute adiabatic, a simulator, or working in a gate-oriented quantum computer. Not only that, because we have many of those vendors that are working on cloud. And this is the natural and more typical way to work with. Very few cases are are in the construction of one infrastructure on premises, including quantum computing. In most of cases, quantum was born in the cloud in the cloud era, and most of the vendors are providing the service through cloud. And this is the reality for all these vendors. Depends on the number of the machine or the size of the machine they are providing in cloud. Okay? For instance, IBM is providing not the last machine, the previous one. So you want to access to the last machine or the newest machine, you have to be in a specific program that this is their network. We will see after that. So this is the distribution of the vendors, the cloud, and this is a comparison from the Chinese, remember that, on three of the main providers of hardware on cloud, Microsoft, Amazon, and IBM, on the different in price interface. So in price, for instance, the highest one is Amazon. The cheapest is IBM. Obviously, you will only access to IBM machines in the cloud of IBM. Instead of that, Amazon is providing to you 4 or 5 different vendors to play with. Of everything. Everything is going to be hybrid, not just only the execution. That this is you are working in classical and connecting with the quantum, and that will be represented like this. You have a process in one determined you stop. This is a stop is milliseconds, and you construct the connection with a quantum machine. The quantum machine is executed, return the control because I say that this is like a mathematical processor for a classical environment because you are making a special calculation in quantum, but not everything. Okay, this is explained more or less in the same way. Obviously, for instance, we have memory in the classical environment. We have not memory here. So the management and the persistence of this information is made in the classical layer, not in the quantum layer. The quantum layer implement the data inside the algorithm. They have not the possibility to manage data external to the code. It's like the things we did in the 50s in the assembler environment, where the memory was very expensive or inexistent, and the code including the data inside, similar to the thing you are going to do. And this is the configuration where we have friends that are controlling the connection with the quantum. People that are making the connection of classical and quantum, that is absolutely needed for connecting. And this is a reality linked to the HPC infrastructure. HPC is supercomputing infrastructure. For instance, Europe has a superconductor HPC infrastructure of 6 countries with big machines. In all the cases, that HPC, that are classical enormous supercomputer, are connected with subsystems that are quantum. Okay, the typical approach of that. But not only the approach is hybrid in a physical way, in many cases it's for solving a problem. We could start making a first approach using quantum or using classical, using this intermediate result for injecting this data for accelerating the process in the other paradigm, classical to quantum or quantum to classical. Okay, and what skills are needed for this level of architecture and middlewares are different. But in general terms, it's a good moment to be computer science or to be engineer or that. And I think it's because most of you are in this master. So congratulations for that. The challenges has been already mentioned: the correction, the scalability, the development of hardware. The software is quite poor. The interface in itself, the protocol, the standards, the people, and the problem of that is related with several problems. Or the situation is the error rate, the number of qubits, and the coherence time, and the 3 dimensions of the same situation, the power of one machine. If you are growing very, very good in a for instance, number of qubits, but you are not solving the coherence or error rate, you will not have a balance growing, so you will not have a powerful machine. And this is part of the discussion we made when we talk about, for instance, benchmarking and so on. And the universal quantum computer, what's that? Okay, in parallel with the people are creating some physical and some practical application, there are people that are saying, okay, what will be my nirvana in the case of a quantum computer? And say, okay, it need to be power, need to be stability, need to be quality of that. Obviously, they high defining the TRLs, and the TRLs has supported by one definition that made this guy, European guy, that defined what are the features that need to be covered by the one machine. Those features, compared with the different technologies we are playing, more or less high achieved. But universal gate, and specifically remember the error rate and the coherence time that we have mentioned, because the main topic defined here is, okay, the qubit, number of qubit, the qubit initialization and so on, but we are suffering this decoherence and the error rate that we have on those lines. This is not feasible. This needs to be more nines in this line to be comfortable enough. 99.9 is not bad, but this is very, cost time cost or and escalate. Rapid ion is difficult to escalate. And you have multiple benchmarking in hardware, software, and so on. This is a reference. I have put here different sources of obtaining in some of that. For instance, I remember when IBM launched the quantum volume, they made a lot of noise. Quantum volume sounds a good metric for analyze the performance of one machine, till all the competition start making or gaining 5 Honeywell and Quantinuum. Quantinuum is the evolution of Honeywell. They merged with another company, European company. When Quantinuum start winning all the metrics, IBM was not interested to push that, and they changed to another metric that sounds closer for them, that is CROPS. This is the reality of the market. Here, an analysis of benchmarking and benchmarking in the hardware, okay, and the performance of the hardware, 1 qubit, 2 qubit gate fidelity. This is the typical minimum measure that we are managing, coherence time, remember, and the error rates. And you have multiple sources of analysis. I have put here super text that this is one of the benchmarker, comparing different machines, physical machine, or even several algorithms, just only for your reference. And related with standards, we have many different standards that could be defined. In fact, we have to work on several of them. And there are organizations, European, American, basically, that are defining different standards for different areas. And we are depending on that for creating a good benchmarking and a good scale for calculate and compare. And these are the plans they have for constructing terminology, the benchmarking, the algorithms, best practices, standards, interoperability, the evolution. This is next, Americans, okay? You will see here different standards that are really right now active and they are under construction, okay? That this is representing of the things that could be defined in the medium term, let's say. But the work continues because there are a ton of things that need to be standardized. Remember that standardization is one of the lack point that we have in this. And the two main institutes, the American and European, that are working here, okay? Just only for reference. Okay, we are in a strong delay. The idea was to show to this in the first half of the session today. Questions so far? Very fast, I'm afraid. Okay for you?
Okay.
Okay, 5 minutes. So in 1947, we will return and we will start with the second part, okay? 5 minutes break. Okay, we will start in 1 minute. Okay, ready again. I have switched off my video because I have receiving constantly messages saying that the resources are limited and we will have probably some problems to manage the voice. I prefer to manage properly the voice and not the image. Okay, ready for starting?
Yes.
Okay, perfect. Wonderful. Let's move to the next 302 slides that we have prepared for you. Remember that I'm going to go by quite fast, okay, but all materials will be, let's say, I hope, understandable reading in, let's say, by you if you want, or accessible to the Moodle. I will upload this probably tomorrow morning. Okay, let's start again. So once we have seen the technology and the state of the art, let's say, and so on, you will see that in detail. And this is changing every day. So it's more important, the source of information, and maintain you posted on the things that are happening every day there, than just only read the slides I have provided you and think that this is the Bible and the last word about the topic. Because, for instance, every year by year, I could include, let's say, 500 new slides in the presentations, because tons of topics have changed, has evolved, and need to be updated. So these are just only an idea of what is the level of evolution that this word is living every day. So that information is static, it's a photo. You need to maintain posted all the things happening offsite in order to understand specifically the area you are interested on, what are the last evolution you see. Okay, let's move on. Let's talk about geopolitics. Okay, what's saying the media? The media today are every day bombing us, deficientes recursos, madre mía. Bombing us with news about what is happening, the typical competition, the people are saying things and so on. The Sputnik moment, what is the Sputnik moment? The Sputnik moment is an effect when the Americans feel anyone else has surpassed them. And the Sputnik moment was when the Russians gained in the race of the access to the moon and so on, the Americans. And from that moment, the Americans, put the machine to the 100% of performance and obtain the first, achieve the first moon man on the moon in a few years after. This is the same situation they live with the Chinese. Chinese, they perceived that it was a challenging country, but they discovered suddenly that the Chinese was more evolved than them in quantum technologies in general terms. And they fall in the Sputnik moment once more. And they put the machinery at the full speed for recuperate the time. And you will see every day, announcements of things that are happening, not just only purely evolution of the market or pure evolution of the industry, in many cases related with the defense or with the military power. And specifically in the States, that typically is in a public environment, everything is known. Chinese are not so clear sharing things, not advances, near advances. So at the end, this is quite simple. This is reduced to a competition among American and Chinese, and the Europeans trying to have a role there in the competition. But the reality is, Europe is the space for hiring new people, new personnel for the big companies that are outside. But this is a complete competition. That this derivative depends on the source of information you read, to a competition that is extended the geopolitical and going through the market, going through the industry. Okay, and we have 2 points to discuss. Show me the money. That is the first, to understand what is and who is moving in that direction. And the second is the threat of the quantum nationalism. Quantum, the first stages, was something quite open, quite innovative, something to share, something to collaborate, discovering together what is happening there, what are the things we could obtain. That has ended. Everyone feels comfortable enough to continue by their own the investment and the research for obtaining the value and the difference, or let's say the advantage compared with the other power. So this is the threat of quantum nationalism. We see very, very simple now. There is the Wasserman Agreement, where the Americans is limiting the exportation of technologies, of quantum technologies, okay, with the excuse that could be used for military purposes or for let's say, market purposes. that everything could be used in two ways. So with that excuse, they are saying that they are not open to export everything. If you want to export something, you have to ask permission. No, no, sorry, because I have export. No, no, permission. And this is the situation. This is changing every day. And this is from McKinsey. The monitor from McKinsey is one interesting report that they deliver every year at least. That this is, I have a lot of slides from that because it's quite updated. And curiously, McKinsey has discovered the technologies in the last year, and they deliver good technical reports and good technical analysis on that. Specifically, quantum one, that is interesting for us. This is the photo investment in the market today. We are talking about more than 40 billion, 42 billions. Theoretically, and this is something that could be discussed, around one third of that investment was made by China, but the China government. Other authors say that China has not invested so much. Obviously, that could be intoxication or could be a fake just only for forcing the Western let's say countries to move ahead faster because the threat of China. Remember the Sputnik moment that we mentioned before. But the situation of the investment is quite clear. Canada was one of the first, and invested accumulated is 1.5 billion close. The Americans started very small because they trusted in their big corporation and companies that are behind IBM, Google, Amazon, etc. But when they discovered that the Chinese was advancing very fast, the money came from the government, and they have invested close to 4 billion American billion, 4,000 millions. Europe, in the combination of all the countries, they have invested 1 billion. The investment of the European community is 1.1 billion. This is the quantum flagship. Now, this is quite well organized, well defined, well distributed, but this is 1.1 billion. Just only Germany has invested close to 5 billion euros. Just only Germany. Remember the nationalists I mentioned? Okay, it's perfect. We are going to put money for the European community, but by my own, I put 5 billion more. Oh, what's that? You are European? Yeah, but it's my country. I need to ensure that my country is the power of quantum in Europe. France has put more than 2 billions, the British 4 billion. So if you add all the investment made just only in Europe, probably we will be the first power of that. But we are fragmented. The European community just only 1.1 billion. Or NATO, the defense organization, has put 1 billion for 2 or 3 technologies. Obviously, artificial intelligence and quantum, the typical suspect are inside. But you could see here the picture. People that arrive very late, for instance, India. India has put close to 2 billion. India, there are people, in the streets with in the bus in the war situation, but they are putting close to 2 billions to this competition. So imagine what is the interest of the power, because the people that will achieve this technology in the correct scale will not share with others. We are in the nationalism of this race. Obviously, once we had discovered that everyone could put enormous amount of money on the top, the situation is some countries need to be allied against, let's say, work together. And for instance, we'll see after, the Americans are signing agreements, one-to-one agreements with some European countries. The question is, European countries, and why not the European community? This is a question I put on the table in some European meetings and say, okay, we are playing that, but we could not avoid that countries could sign their own agreements. Okay, perfect. But imagine a state with Finland, that is a real agreement that has been signed. Obviously, Finland has not the same power that will have the European community. But once more, nationalisms appear. In the case of Spain, they are not talking about 50 millions or 60 millions I put here. The reality in Spain is very poor, is less than 150 million. The idea is to grow that, and we are waiting the launching of the Spanish strategical plan. This is the representation of that in other lines. If you put all together, the European countries are investing more than China, but we are distributed. This is a confederation, is not a single country. Okay, and this is the evolution of the investment. You will see that in 2022, the peak was the highest. From that moment to now, that decreased. Why? Because the generative AI appears, and they capture a lot of money. Once say that, you will see that the decrease has been basically focused on private investment. The public investment even has grown. And this is the comparison among the 3 main powers, China, States, and Europe. So every country that has to be someone in this competition, in this market, has delivered the strategic plan. And this is a summary of the different strategic plans. The Australian, the Canadian, the China, And these are a description. Sorry for the size of the. This is difficult to read, I know, but this is a script describing what are the different programs of the different parts of the plan, of the strategic plan that was delivered. Obviously, one of the topics that everyone in the world wants to have is the best research centers. So there is a strong and fierce competition for attracting the talent and attracting the investment of that research centers. You know where the centers are based: the States and Europe, Western Europe. Don't hesitate and do not misunderstand. China is investing enormous amount of money. They have the possibility to concentrate that talent where they want. They are not a free economy. They are not a democracy. They could make with their citizens whatever they want. And in fact, they are doing though. They are doing so. And they are investing billions and billions, very concentrated. Probably this will be an objective for the atomic bomb if they want to destroy the program, because China has not so distributed. They are very concentrated. Okay, and this is the initiative, the country initiative, with the date and the amount. This is the plan in many slices at the same time that the states has delivered the big plan, the big view of the plan, and then they are delivering from time to time one part of the tailored plan they have constructed. And these are the countries that are putting money in the different technology that we have seen in the previous part of the presentation. But this is not just only a question of countries. Even inside every country, there is competition. For instance, this is not a recording here, but Michigan State published a very few weeks ago that they are going to put $500 million just only in the regional, in the state quantum program. And this is happening in many cases: Bavarian, the Calgary University, one part of the Canadian, or inside the Spain, in Vizcaya, or in Catalonia. Or in France, the south of France wants to become the, the valley for quantum. This is a competition where even cities are putting money. This is the analysis of New York City. That is what will be the positive or negative impact that convert New York in a quantum hub could mean for the city. And they say, okay, just only 332 billions of new revenues and 95 jobs of high qualification. That means very good, let's say, well-paid people living there, not just only for the economy of the city, the economy of the citizens. Many people are thinking of that. Barcelona, for instance, is a sample in Spain, but there are other cities that are making this type of analysis. And this struggle of the countries has representation in several areas. For instance, in publication, one of the things that are measured every day is how many publications. Number one in publication are the European community by far. What is the problem? The European community is the worst for putting good publication in real innovations. Let's say return of that investment on new ideas, on things that are positive for the economy of the country. So we are number one on publications. We are number one, this is a spoiler, in talent, but we are the third on putting this talent and this knowledge and this research in reality in the economy, in patents, for instance. These are the distribution of the countries that are producing more papers. Curiously, the number one is States and China, but if you add everything constructed in the European community, we are number one. And this is the comparison. Depends on the paper. For instance, the number one institution of delivering papers is one institution of science in China. Around 5,600 papers published. What are the companies that are more focused on trying to publish things? For instance, Microsoft is number one on this analysis. Or university institutions of companies in the States. So these are the nature of the papers or the type of paper that are delivered. And these papers, publication, this is knowledge. What is the way to convert that into something with value for the industry, for value for the country, for the citizens, for the society? These are, in many cases, one of the metrics uses patents. Number one in patents, the States. Let me think. So we are the third or the second in publication, and we are the number one in patents. They are very clever converting this knowledge on patents. And in fact, the States is the number one attracting talent, whatever that talent will be. And this is because, for instance, states are signing agreements with Finland. Finland is a good country, but the size they have with the talent they have inside. So it is interesting for the states capture that talent for their companies. And what is the way to obtain that? Sign an agreement with the country for making it easy to move the people from the Finland to the States. Second one, Japan, Germany, China. Oh, Germany, not bad, but Germany is not Europe. That's the difference, okay? Patents of different flavors, okay? The different nature of the patent themselves, what's nature of that, or even the companies that are patenting more or less. For instance, in this report, IBM was the first one with more than 400 patents on the family of quantum computing, just only quantum computing. This analysis has been well reported. There are several institutions that are constructing reports explaining nature by nature, country by country, company by company, what type of patent they have. They are categorized as everything, and you could analyze what is the evolution of that if you want. This analysis was obtained in the last year, probably will be the last one of the European Patent Office, but you could obtain when the new ones appear and update that data you want. Even it's analyzed what is the source and the collaboration among those countries and those areas for making those patents. And you will see what are the flows of knowledge if you want to analyze this in detail. It's very funny, okay? And obviously, this is not the end. Obviously, the potentially construction of value for one determined economy or one determined power is supported by the creation of value on creating new companies or creating companies that could grow and convert and transform the economy, typical startups. So another metric that we used to see what is the level of application of that is the number of startups that we have launched. The top 7 states, Canada, United Kingdom, Japan, France, Germany, and China. Don't be confused with that. China are creating very, very strong startups. But don't remember that China has enormous companies behind and inside. So they could construct new companies, startups, but they could invest enormous amounts of money also in the companies, the big corporations they have inside. In fact, the Chinese government, apart of putting 15 billions on the table for research, analyzing and develop, blah, 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 they have suggested, okay, with care, to the company they have, Tencent, Alibaba, etc., to put the same amount on private investment on developing the market. But anyway, returning to that, number of startups is also another ratio, as you could see here in detail. We are not the best, but we are not bad in Spain, but not significant compared with other countries with much more presence there. Applicant, once more, okay, number of companies, one number of startups, you have seen the nature of every startup, or even what is the startup that has received much more money. Not just so important is the number of startups, is the money that every startup are receiving for growing and for developing their market. Obviously, even in the case you compare the number of startups in Europe with the number of startups in the States, you will see that there are 4 times more muscle or financial muscle, the startups in the States, in average, than the startups in Europe. That means that every startup in the States has 4 times probably more possibility to survive financially, let's say, thinking that all the startup makes sense with the products they are constructing or the services they are constructing, they have much more possibilities to grow in the States. This is because most of the companies grown or born in Europe, they have the intention to create branches or even to be moved to a market that have more opportunity to finance the revolution, the American market. That's okay. This is the rules of the game with the current economy. And in fact, one of the biggest problems that we have in Europe is the lack of big corporations. For instance, the States and China or Japan has enormous corporations, but we have not the enormous corporation that we need for develop this market in Europe. Do we have any Amazon, or do we have any Google, or do we have any IBM, or any Hitachi, or any Fujitsu? We have not that companies inside Europe. So one of the let's say the weaknesses point of the evolution of our market is the lack of that type of companies where we could, multiply the effect of the new startup we are creating. If we, as a European, don't play with care, or startups will end their life in the States, multiplying the effect of the evolution of the economy in the States because they multiply the effect of these big corporations to take advantage of these advances. Or just only simply to purchase it. Or imagine a company like Google purchasing a European company with extremely good software that need to be integrated. Do we have a company like Google in Europe for taking this or capturing this and multiply the effect of this development? No. Okay, but this is the rule of the games because this is a geopolitical problem. This is a distribution of the startups we have, depends on their nature, the concentration by year. Don't forget that the number of startups has decreased, but the money in every startup are growing. So this is not totally representative of the reality of the startups today. And not only that, we have also regions and strategic movement in regions. This is the representation of the different, national quantum strategical programs. Okay, this is the launching of the quantum flagship. Australia, Japan, China, Singapore, and UK, for instance, had previous plan than the launching of the quantum flagship. And after launch has to deliver the same plan. Or the British has delivered new updated and new developed of that plan, the same as the state that I mentioned before. The nation, what that plan typically includes, something related with public research, something related with education, because they're aware of the lack of the talent. The typical creation of hubs, the consolidated research centers in hubs that will have let's say, synergies among them. They develop the ecosystem, that this is new startup, the injection of money for new plans, new use cases, etc. The creation of supercomputing center, the HPC, plus the quantum beside, the industry, the injection in the industry, the possibility and the need to take advantage of that. This is the unique way to feed the ecosystem themselves. Or for instance, the helping on the launching the new startups. Thought the startup like the catalyzer for some of this evolution because they are more flexible, easier, fresh to make the things. Okay. Or for instance, to sign a specific partnership. As I mentioned, the partnership among the state and Finland, but not only Finland. The state has signed with Sweden, with Finland, with Denmark, with etc. etc. Okay. And typically a connection with other allies in the same economies, connection with friends countries. And there is a role to play for the different governments. The role of the regulator for a standard and the safeguard of the investment, for instance, the patents management, the buyer, because we expect that the government will be one of the big investors of that, and buyer of these services that has been delivered, constructed, and supported by the economy. And obviously, the generator of the role, the talent, because as IBM, I could create my own university, but really this is not this is not feasible for all the companies. So we could expect that the government make the movement or the sufficient movement to create talent programs for create the new talent workforce at a scale, because every company will be interested to train the people in their own technology, typically, as IBM with a lot of clever approach did in the last or during these last years. But we have, let's say, agnostic source of talent country by country. And this is where Europe is number one, but Europe is creating the talent for being exported to the States and other countries. This is the situation, a flash of the situation of the status of the different countries, about the movement of capital, the research, the number of investors, the patents generated, the papers, the publishing, the new ideas, the companies. You will see here that this is obviously because the size of the different European countries, obviously, the Moscow scale is not big enough. So here the scale is also important. Ideal collaboration. This is a photo taken in the first meeting where the White House invited all the European, let's say, Western countries with a strategic plan published. You will see here the Australian, the Danish, the Dutch, the German, the French, etc., etc., because they perceive that they need to coordinate the effort of the Western countries in order to be more competitive with the challenge that the Chinese country is having. Okay, Japan, for instance, was included here, understood like a Western country. So here, let's say the big competitor is China. China was not invited. In order to coordinate that, and they have signed, for instance, an agreement, as I say, use with Finland, use with Sweden, etc., etc. What is the situation of US? US in general terms, one of the big contenders in this race. We have here in front of us in the US the situation more extreme related with the orientation of the quantum program, because two of the three pillars of that program are not civilian, are defense and intelligence. So they are quite injected of federal money, focused on the typical DARPA programs, defense programs. And it is curious. You see the publishing, you will see that the Marines are signing an agreement with a startup. The Air Force is signing an agreement. The NASA is signing an agreement with, or the NSA has purchased a computer, that this is a reality. The first computer purchased, that was the Wave years ago. We are talking about 2014, 15, was Google, NASA, and CIA. Okay, you can imagine why they are interested in that. So two of the three pillars of the state program are focused on defense or security. They was the first one creating an ecosystem, creating let's say, QADC, that this is a consortium. We will see after some consortium. They created a map of connection. They are very good on connecting the universities and the companies, and they are creating a strong network. And in fact, inside and outside the States. They are colonized Canada, for instance, but there are a lot of links with European universities and European companies. They have created an ecosystem, a blend of universities and companies. In many cases, they are trying to diversify, not concentrating all the eggs in the California. They are distributing things on Texas in the south, on New York, around Chicago, for creating new hubs of knowledge, not just only concentrated in the valley as the classical environment. Okay, talent, a lot of investment. There are a long report from the state, more than 60 pages, explaining what are the plans related with the talent creation. But even in the case they have perfectly defined that, they have a need of new, basic mature, that is people, head, and they are capturing that talent outside Europe in most of cases. The companies that are on top of the development of that and the evolution of those companies, or just only for a reference. You want to read the more China. Situation of China. China has a strong governmental program. You know, as I mentioned before, the 15 billions that everyone in the state has said that China has invested has not responded by China. China has said that they are investing less billions. In fact, you could see here the published billions, that is around 8 billions, but not they are not 15. Anyway, this is part of the fake world that they are living today in the economy. So who cares? They are investing billions and they are a power that has advanced in communications, for instance, and in some extension, depends on the moment, in computing. So they are competitors for the states on this commercial war. They have created infrastructure, very sophisticated, the communication lines that they created. In fact, they constructed the system with the knowledge of Europeans, in that case, it's an Austrian from one university that made the test in Spain. So Spain didn't see anything of that testing that was made in Canarias Island, and was developed and deployed in China. They have the ecosystem, they have a network of connection, internal and external. They have their own ecosystem of companies providing computing, software, telecom, sensing, etc., electronics, basic electronics. They have providers that no one knows because they are local, but they are extremely strong because they are a concentration of money for making the things. They are providers of computation power, the evolution of those competitors, and they have real good advances in QCT technology. This is communication, in infrastructure, in repeaters for making a network. Probably the biggest network in the world today in communication are Chinese, and they are experimenting with satellite communication as well. They have quite advanced in security. This is the threat against the broker of the security of the rest of the Western countries, obviously, and they are good advances in computing. Not as, let's say, as sophisticated as the ones that are made the IBM or Google or others, but very secure. And these are the last news received. China has delivered 176 qubit machine, and they have obtained extremely long communication among repeaters of more than 1,000 kilometers. This is the record globally. UK, they started one of the first. Their program is quite oriented to dual use, military and commercial. And there are tons of documentation regarding the evolution of the plan. Every year they deliver a book, they deliver a report explaining what are the advances and the next step. Quite complete, well constructed, well defined, well made. They are constructing also a communication network, disconnected than the ones that the Europeans are constructing, but evolving. And there are challenges. They organize the evolution in different challenges for solving specific problems. Quite practical. They are British. This is the photo of the web page where they have the ecosystem published, and you could theoretically connect and show what are connect or be in contact with any of the stakeholders. You could see here a static photo of that. The ecosystem, the companies, they are quite active in creation of a startup as well, and they are once more, as the Anglos in general terms, well connecting the universities with the real economy. Big corporation and startups, both. Okay, they have the ecosystem quite developed. Germany, we could talk about multiple countries. I have only included Germany and Japan as Spain, by obvious, but we could talk Holland, Israel, India, whatever you want. There are quite interesting reports during the last 2 years regarding most of the countries. Germany, the number one investing inside Europe. Last week, we received a news that said that IBM was going to deploy the first physical machine outside the States in a HPC center in Germany. So the first machine that IBM is going to deploy outside the States is going to be located in Germany. Jülich is the HPC center number one there, and the federal government has a lot of agencies and a lot of interesting teams. For instance, the Max Planck is number one, or Fraunhofer is another interesting and extremely strong research center. They have, as usual, their ecosystem, the universities, their companies, and they are investing a lot of money in their own company for develop the market. Okay, you could see here a map of the companies that are active right now in Germany. A part of that, they created an ecosystem, and a specific consortium. Their name is QTAC. The QTAC was only for German companies. If you want to participate in QTAC, you have to be invited by the German government. No one is able to participate that outside Germany. This is a reality because I tried to be part of QTAC because I was working in a multinational in one of the big four that we mentioned in my introduction and so on. And we tried to be there because obviously we had branches in Germany, strong branches in Germany. But when we asked to be inside, we were rejected. Why? Because we were not invited by the German government, and they are creating, specifically in the QTAC, a set of applications. They are organized, the different big companies that you see here, that are enormous companies, multinational companies, they have organized by sector, and they say, okay, Bosch, Volkswagen, Mercedes, I invite, construct a set of use cases for one determined usage. And they have constructed a list of use cases that has been published partially, obviously, partially. And this, the way that the German government has for capture this knowledge, join those companies to invest together in many cases, and they have put money on that consortium for creating their own German ecosystem. Or Japan. Japan is quite isolated. Poor Japan are far away of the rest of the people, but they are putting billions as well. And they are creating well-organized ecosystem. The advantage of Japan in this case is the existence of big corporations there. Okay, just not the typical ecosystem and innovation hub that we have here. We have enormous companies that has enormous muscle. For Fujitsu, for instance, is one of the biggest competitors of the American companies on constructing a quantum computer. And they have working on digital emulators, and they have working also in gate-oriented that are going to compete with IBM, Google, etc. Okay. Okay, and then we arrive to the Spanish case. The Spanish case, and sorry for that, we were interested to share a little bit about the Spanish case because obviously this is a Spanish master. We thought that a good amount of the people that are participating here are Spaniards. So the situation in Spain is quite clear, and it could be summarized. Brain drain. Imagine a Spaniard as responsible of quantum in IBM, one of the head of Microsoft in quantum. They're responsible of creating the use case that gained in 2019 the supremacy for Google. One of the head of Raytheon is a military company on quantum. This guy has been moved to Singapore Center of Quantum Technologies as well, moving the Center of Excellence that was launched or was one of the founder on IQM. He left IQM, today is in Kipu. Enrique Solano is Peruvian, but has developed his career in Basque Country University. And many others that has been invited many times to be outside. And there are people, this is the number one in communication from the UPM. This guy is the responsible for the CSIC, the research, the Spanish research that has been many times invited to deliver and to lead quantum computing. This is Complutense University of Madrid, etc., etc. Ana Sampere in Barcelona, or for instance, Veronica Fernandez, who is the responsible of the CSIC for communication. Extremely good talent. What is the problem? That talent, once is discovered, is attracted by the money outside. A part of that, the government created some years ago the Quantum Spain program. It's modest, let's say, in money, but they are making some movement for creating the first Southwest quantum computer based on technology in a quantum company based on Barcelona named Kilimanjaro. And they are creating the first approach on hardware. But this is not the unique one in Spain. There are other initiatives in other regions. A part of that, Spain put money in the complementary plans related just only in quantum communication. Curiously, quantum communication has around 70 millions, and the quantum computing has 50 millions. Today, the situation is this one, probably will be switched in the near future. A part of that, for instance, the Galician local government has signed with Fujitsu, and Fujitsu has installed a machine there in the CESGA. Oh, this corporation, these different companies, has invested in develop Barcelona or Catalonian environment. Or Basque Country has signed the first agreement for having access to the IBM machine outside inside Spain. So they have access. This is Dario Gil, the Spanish leading quantum in IBM, is signing the agreement with Lenda Cari some months ago. But this is part of the evolution of the different regions in Spain. If you see where are based the people that are moving things on quantum, this is quite concentrated. Barcelona, Madrid, Basque Country. And another interesting is the CUCO. CUCO is a consortium, not intervened by the government. It's a consortium on private companies working together. This was launched inside the MIT infrastructure, let's say, environment, okay? But in reality, the CUCO program has delivered many different use cases tested in real companies with real data. That's interesting. A photo of the consulting big companies that are based here that are working on quantum, startups, organization. For instance, ICFO is number one globally in photonics technology. This is a generator, for instance, of startups. Some of the startups more successfully, specifically in Catalonia environment, came from ICFO people. ICFO make spin-offs of some of the development, and they have specific companies like, for instance, QCT or Lux Quanta that came from ICFO, that has a good research center, world level. Let's say this is the number one and number two at worldwide on photonics techniques. Other organization like CSIC that has good reputation and specifically in communications. Or Ametic. Ametic is an organization that is aggregating companies, market companies, private companies. And for instance, I belong to this team from the early moments. We have delivered a couple of reports, one in Spanish, the first one, and the second one in English, where they have explained to the let's say the companies in Spain, outside Spain, what the quantum computing is, what are the main topics, what is the way to deploy that, interviews for companies that has experience, Spanish companies that has experience to implement algorithms in real life, this type of stuff. These are the reference to both reports. And talking about consortium, we have consortium that are pushed by governments or by institutions that are close to governments. For instance, QDC, the American Quantum Consortium that I participated in the launching as well. This is our friends from Japan or Quantum Industry Canada. But not only, there are many other consortiums that are industrial, private initiatives that could take into account also because they are quite specialized. These two first are focused on pharma. But we have many others. For instance, this is focused on internet, or this is focused on engineering, or this is focused on security, or this is strategical. This is the high-level point of view for CEOs, CFOs, CTOs, etc. These are different approaches. In fact, the biggest one agreement of consortia of consortiums, okay? And they have periodical contact and interchange of knowledge. All of these consortiums typically deliver papers. So not all are public. Many of them are for members, but you could access probably all that information, the public information. And this is quite good because they're analyzing use cases or they're analyzing the situation of one determined technology or the evolution of the roadmap of whatever. So for many of you could be a good source of information to explore the data, explore the reports those people are delivering. QDC and in general, all the consortium has a similar structure and similar targets. Okay, this is quite similar also to the strategic plans. The first one delivered and the rest are copying a good percentage of that because it makes sense for them too. QDC was organized by the American government. They created a consortium inviting most of the biggest companies in the States and many companies that don't belong to states regionally, but could be interesting for the purpose of this, because they invited companies from Europe, companies from Canada, from that for creating the variabilities, the sufficient variability to obtain different inputs for creating or for supporting the creation of the ecosystem in the States. These are the members. 2 years ago, probably we will have much more than now, but this is public. You could access to this information. And this is the teams that I have created. One team focused on enabled technologies. Another team for law, another team for use cases, another team for workforces. You will see similar teams working, for instance, in the European one. This is the photo taken last year in May. We have a plenary meeting in Madrid. And we even, in fact, I was the organizer of the meeting, so I know quite well everyone there. This is the Quantum Europe. These are some of the companies that was in the first shot, and this is the distribution of company. Curiously, the number one in company is Deutschland, and the next one, I think, was Spain. In number of, United Kingdom, sorry. Germany, United Kingdom, and Spain, the three countries with more present on the ecosystem, or more present in the consortium. These are the work groups. We have, for instance, the different, remember the pillars of the European community? Okay, enable sensing, quantum communication, computing and simulation, this was joined. The transversal use cases, roadmap, intelligence, property, patents, standards, education, ecosystem development, funding for the specifically for the startups, and chapter, national chapter for aggregate those information, thinking on every big country. Not all the countries present in the European community has national chapters so far. Okay, that this is more describing the description of the things they are doing. Or for instance, the Japanese, the Questar, well-defined, different focus areas, very similar. They are proposing making a specific thing. For instance, the Japanese in the last they deliver application, an application using a product from Microsoft for managing the members of the different ecosystem, the different consortium. It was quite funny. The graphics were good. Another, the Quantum Internet Alliance, obviously very focused on European countries because it's an European initiative. Or PASCANs, similar, okay? Or the Queer, There are many others. Remember the list I present there. You are interested in any of that, I will invite you to go through internet. You will find tons of information. What's about the European quantum ecosystem? This is coming from a document that European scientifics sent to the European community. What's the Quantum Manifesto? They are saying, hey guys, the race has started. We as Europeans need to take into account that the quantum race means investment of money, creation of capabilities, ecosystem, blah, blah, blah. The Quantum Manifesto was the launching of that. The European community took that like a notice and created the quantum flagship. 1.1 billion or 1.2 billion, okay, but was peanuts, thinking in just the investment of a German country. 1.2 billion for 10 years of development for 27 countries. German country has multiplied by 4 or by 5 this investment just only for Germany. But in the case, even in the case that we are living the nationalism or the quantum nationalism, the clear message at the European level is Europe is bidding on this, and we receive a lot of push from Angela Merkel, for the French, for the Spanish, for everyone for pushing this program. This is the evolution of that. Are you familiar with this? Because it's the definition of the different towers I mentioned, and that was evolved and has a plan or a roadmap in this case. We are at the middle of the development of that to the 10 years. Remember the launching of that till the first set obtained in the next 2 years, and the plan till the 2035. In fact, we are living right now a 2030 plan that are going to be delivered soon. And this is the evolution of that to till the 2030 plan. What is the level of evolution, and what are the different plans that has been published that European countries are going to launch? But this is an ecosystem of plans. Exists not just only in flagship. Exists Quantera. Quantera is a mechanism for investing in plans or investing in projects. Exists the metrology network, focus on quantum and non-quantum sensors. Communication. The intention of EuroQCI is to create in the future a parallel quantum internet, connecting every country in several nodes. For instance, in Spain, we have the node in Barcelona, Madrid, Galicia, and Bilbao, I think, for a starting point. And that will be extended. So we are creating an infrastructure, investing a lot of money, because that is not just only pure research, it's deploying components for making that communication, quantum communication, a reality. We need specific devices and specific features for instance, for the lines. We are going to use that are terrestrial, or infrastructure that are focused also in put vitamins in the HPC supercomputer network. In fact, they have been published the supercomputing new network with quantum. This is the structure of the flagship. I belong to this team, the advisory board, the expert reviewing the plans, supervising the strategy, etc., etc. Very interesting. Was more than 1 year, but is this one? Quantum communication has 4 projects, or quantum computing has 2 projects in the first definition, or basic science has 7 projects. The project are this one. The project included the need of creating companies, startups or companies, beside the plans or beside the analysis or beside the research that was made. They have created an enormous map of experts, or they manage and control it at the European way, German way, let's say. And most of these companies are delivering their own plans and going ahead because they are supported and covered by the plans the next 10 years. A lot of success inside these companies. They are small, but with good things for helping others growing or for injecting this knowledge in the economy. This is the difference on investment among Europe and the States. A little depressed after seeing that, but okay. And these are the more, let's say, successful tech company created with private investment in Europe. Quantinuum is a consortium about one enormous company like Honeywell and CQC, is Cambridge Quantum Computing. It's a company born in UK. And these are the people that was beating IBM when the quantum volume was defined, that I mentioned before. But IQM in Finland, Pascal in French, etc., etc. Interesting companies has grown there. And the ecosystem that we are creating in Europe, basically around all these lines, incubator, competence center, design something to the, let's say, to the market. We want to create ecosystem. And the point is here, we have plans, rolling plan, develop plans, etc. This is a photo, for instance, of the network defined at the end when QCI will be operating. The network parallel to the the network of quantum communication in parallel with the internet network that we have currently for the classical environment. You will see several nodes. The active ones, aside, for instance, in Spain, is Galicia, the hard planet, for instance, the communication with Portuguese nodes. and the rest of the region of Spain. Similar situation in other European countries. It's not exhaustive, but it's an idea of what are the ecosystems that we have created here and what are the cities preferred by the Stirling and Cambridge in UK, and Barcelona, Helsinki, Innsbruck, Madrid, Munich, etc. at the second level. And the top countries in number of startups, etc., etc. The ecosystem at the European level is defined in different layers, seeing what are the companies that are creating basic components for the rest, basic materials. On top of that, the hardware. On top of that, operational environments. On top to the stack we show when we talk about that. And what are some of the centers that are really or the hubs of research that exist in Europe today? And then go to market players. And we only have 18 minutes for the rest. Let's move very fast, as we are going to provide to you all these materials. You could read that and go in deep if you want to in any of them. So I'm going to just only put highlights. These are the map of those companies. We are going to be focused specifically the biggest one. Okay, this is a map, detailed and more detailed map. But this is the evolution of the quantum computing industry, and what is the stage that we are living. Obviously, we are here in the middle of the niche area. Niche area means that characteristic, that feature, and we will see what we expect to find in the next years. This is a map of analysis, very interesting. These people is difficult to take, to catch TVR, but TVR are making an analysis of the different big companies like IBM, Atos, Accenture, Microsoft, QCT2024. What are the configuration, or what is the level of knowledge they have? A different area, application discovery, IT skill, virtualization, and innovation. And they say, okay, IBM is mature in everything. Okay, no surprises. In everything except application, it is a communication player, makes sense. This is not the last word, or this is not the Bible. But this is a first approach that provides to you a lot of information on what is the configuration, or what are the companies that are investing more mature in what area, or whatever else. Or for instance, this one, there we have make this and another. What are the main companies that I have? This is the good square in services. All the way, for instance, number one in another. Or Zapata in software. We could discuss about this because Zapata has changed the scope recently, and they put the stress on artificial intelligence. So they are pushing artificial intelligence combined with quantum computing. If I have to choose, I will choose artificial intelligence. In fact, the name of the company today is Zapata AI. But it's okay. It's like one qubit or QControl that are constructing that are today still on the market. In the same way, by the supply and the level of innovation they have, another perspective about innovation. Okay, we have a lot of analysis, and every day someone is creating a report and putting on the market. So just only keep only like a list of sources of information that could be valuable for you. This is another source. This is Kureka. Kureka is a company very focused on training and talent creation. Okay, Kureka are delivering typically and publishing a lot of graphics like this one. What are the nature of the companies that today are playing on enable, and 18 on hardware, 20% on software? Okay, this is a photo. A lot of people is requesting. Kureka was a company created by the Colombian living in Spain. Okay, and today they are living typically in the UK. And even in the case the original branch was in Spain. This is a report that I love a lot because it's the first analysis I saw related with the 500, the global 500 companies, and analyze what are the impact of quantum on these 500, the global 500. And they say 30% of the companies are European, 16 and 15 are basically Brazil, in the 500, and the implication of those companies on quantum. What are the more typical type of usage of these companies on quantum? Most of them are exploring or optimization or are making simulation. In semiconductors, this is a little tricky because they are talking about the biggest one, Intel, Qualcomm, Google, this type of companies. Okay, they are ready. Aerospace, no surprise. The second one, Airbus and Boeing, they are both of them deeply involved in quantum programs, specifically Airbus. That this is quite curious the approach they have on the market there. Pharmaceutical companies, telecommunication companies, etc. Or for instance, what are they investing? And number one is IBM. Or the wave when we talk about optimization. Spanish startup, Multiverse, is the second one in exploration, making analysis and proof of concept in the companies. The first one is IBM, the second one is Multiverse. Interesting information. Or for instance, what are the number of use cases they have published? JP Morgan, the bank, is quite generous explaining the cases. In fact, they delivered a paper a couple of years ago talking about the implementation of 9 cases inside their infrastructure of machine learning, artificial intelligence, and quantum programs. 9 explanation in an article and no more news. Remember when they are talking about, or we are talking about stealth mode, the saying that the sovereignty / the privacy of the information among the powers are happening between the companies. The companies are saying that they are doing things, but they are not providing any detail. You know, the power of the knowledge If I have that, why to share my advantage? Invest by your own. Okay, and in the race, this is something that is changing every day. In IBM, we are here. We are waiting for the Polish IBM is deliver their advances, or they are delivering their milestones in November every year. So we are close to see the new announcement. But last year they say that they are abandoning the race of growing the number of qubits in a simple chip. And they are changing the scope, making architectures, hardware architecture and software architecture for creating like cloud in different layers using a strong chip, but in different layers. Instead of making a bigger chip, connecting in parallel multiple chips, creating an architecture that allow them to grow to achieve, the nirvana of millions qubits in one determined year. So this plan, let's say what they are going to deliver this year. This is foreseen if they are continuing with their original plan. Let's see. But you have here a photo that this is for sure not totally accurate today because everything is changing every minute. And there are roadmaps for most of the biggest companies. Roadmap that has published, and I have put here some of the development on different companies. For instance, Microsoft is in piloting, or QDOR is just only in the thinking. It's trying to analyze, making proof of concept and so on. Honey, the situation, we are going to see very, very fast a photo of different companies. Honey became Quantinuum, as I say. They joined it with CQC, the British company, and they created a new company just only focused on quantum, named Quantinuum. Quantinuum has delivered two big machines, the H1 and H2. H2 is the number one in power, let's say in quantum volume, using that metric. The metric changed if the people that create the metric decide to change that. For instance, I said it before. But it's an interesting case because they are playing with a technology that has ions, and they have a strong performance so far. These are the plans in noise in the market that they are constructing proof of concept with many companies, and this is the roadmap they have promises to construct. They are avoiding this configuration and start creating, aggregation and a more complex architecture for making more powerful machine. IBM, tons of documentation and information related with Hill. This guy is from Murcia, Spain. And this is one of the visionaries that the White House invites from time to time for make, the typical consultancy related with the technology evolution and technology and so on. This guy is not just only the VP of innovation, not only the VP and responsible for quantum, he's responsible for IBM innovation in general. And this is the approach they have. The future for IBM is a mainframe as everything related with the classical cloud, that they are one of the biggest providers, neurons, the artificial intelligence in scale, and qubits. And for them, the future is the combination of these three that they represent in this way, saying what type of services and what type of delivery would make with any of these blend. The last machine they delivered was Condor, more than 1,000 qubits, but this machine has been not abandoned officially, but substituted all chip, more secure chip, more industrialized chip that is able to be connected in parallel to construct more hardware architectural for growing the number of the power of the machine. So they have said that in parallel to the plan and the roadmap they have opened a new line based on Heron process. This is the line the Heron delivered the last years and the evolution they are expecting. Heron will grow. These are the typical roadmap that they deliver, very interesting because they are blended. The hardware evolution, the middleware evolution, the software evolution, and the solution evolution for the market. And they are saying, year by year, what are the intentions? This will need 15, 20 minutes to explain this in detail. I will invite you to do a look on detail of this, quite interesting. And they have a strong ecosystem inside their own infrastructure. They have different flavors of Qiskit. Qiskit Finance, Qiskit Machine Learning, Qiskit Optimization, that is supported by Qiskit Terra, that is the simulator. And they have behind Qiskit is IBM. The other, let's say, but this simulator and this different layer, the simulator, the Terra, the Qiskit, and the combination that makes this a quite a strong architecture. This is the method for use Qiskit. Do you remember the transpilation that is needed because every machine of IBM are running the different way. So the transpiler is the way to take a simple algorithms and deploy in all the machines. In the making independence, the algorithms or the behavior or the performance or the features of one determined machine. The first facility outside the States will be in Enningen in Germany, and this is a guy that probably you see in the news every day. That has the signature from Germany. The signature from IBM was Dario Hill, the guy from Austria. And these are the ecosystem that IBM created. And what are the members came from? They're people from the world. And they are creating a strong list of companies that they are working and investing and making development with them, okay, by industry and by country. And this is the typical screenshot of the cloud services. You will see that this is quite, let's say, predictable. IonQ. Okay, the Wave, they have a plan. Remember that I said that the Wave has opened a new line of development, focus on gates, because they are perceiving that annealers will need enough for surviving in the near future. So they have opened an alternative way to continue as operation on a company. And this is true because the annealing has a window of opportunity that this is not totally closed, but is going to be closed in the new family or new generation of hardware that are going to be. Or Microsoft. Microsoft has not today a hardware. They are an integrator. They have it's just only a cloud that they are aggregating different vendors. This is the list of vendors that are available is Microsoft Simulator, IonQ, Pascal, Toshiba, Quantinuum. These machines are available inside the cloud of Microsoft. Meanwhile, the hardware investment of Microsoft that is focused on one of the more exotic type of approach that is Majorana particle, that is the topological approach, a very challenged technology. If they gain this race, they will be the winner of the big race because topological has a condition of execution much better than the other technologies, superconductor, NV, etc., etc. Meanwhile, Microsoft is investing on developing middleware for making as usual in the history, make the things as easy as possible to develop. Okay, Google are playing everything. Google has their own development on Sycamore. Sycamore was the machine that they delivered. No one has touched Sycamore outside Google. So this is at the level of lab inside Google. They have not delivered anything commercial, but Google in parallel is working on software, cloud software. The idea of the Sycamore is gained, in parallel, similar strategy that the IBM is taking. Intel, this is one of the last in the competition in the race, but they have money in a scale and they have a story of success. In fact, Intel has signed with Delft University in Netherlands. It's very strong in hardware. They have the R&D center there. They are constructing not just only the hardware itself, the quantum chip, they are constructing there. And they are proof of concept and investment apart. Amazon that has their own hardware program. In fact, is the research center that they have in the Valley, in California, their own hardware, the development of the middleware, the development of the cloud for integrate multiple external providers like this one. Okay. And some of these providers are not provider of hardware. They are integrating hardware and software vendors. For instance, this company is a Spanish company, an Israeli company specialized in error correction and error prevention. They are making a blend of hardware and software vendor for creating a good stack of, remember the architecture we described before, a good stack of elements. And there are other cloud providers that are distributed in this way. Basically, they are the biggest 13, Chinese and American, basically. Okay, and what's about the startup system? This is the VC company. And this way, they are putting money and they are concentrating the money they put in less and theoretically more successful startups. They are not distributing the billions they have available. Multiple companies, they are trying to concentrate for creating the most scale enough for being more or provide more opportunities to those startups to win the race. And this is the distribution of Series D, Series A lot of details. So before, sorry, we have seen in the last year, we are growing in the lowest rate the number of startups year by year. This is not decreasing. This is growing lowest, in the lowest level than before. The tendency here is growing very fast. Now it's growing, but not so fast. And this is the distribution among the typical startup. In equipment, at 39, 8%. So you have here the companies with more money. Remember Quantum, the company that trying pursuing the full tolerant quantum computer? They are attracting a lot of money, specifically for US government, as I say. Okay, the companies has created the big amount of companies and the process of concentration we have made, or we have said. Some of these companies has become public. It's the typical SPAC program. You will see here that the SPAC has not been very successful. Rigetti and the Wave, as if more money and more investment, are maintaining more or less the level. But Rigetti and the Wave are suffering a lot in the market. And about the distribution, something that we saw before when we say about the competition, States, Canada, United Kingdom, and the number of startups and the nature of those startups. Okay, that's only more or less the same information. Regarding the money captured last year, Pascal in France captured a lot of money last year, more than 100 millions. This money came from the French government. Everything has to be said. Okay, and the nature of these startups. Okay, and we have on time, even in the case we have run a lot of slides in the last 10 minutes. Okay, as I said, this material are going to be uploaded in Moodle probably tomorrow morning, and the recording of this session as well. So it's time for questions. If you have live, because I understand that after 3 hours of bombing, that could be tough. Question, please. No questions? No questions. Okay, so thank you very much for your attention, for the survivals in the discussion. I know that 3 hours with 700 slides could be tough. It's not important all the contents of the slide, just is a reference for you, will be your small encyclopedia of quantum topics. We will continue with the bombing in different topics on Thursday. So more than happy to see all of you on Thursday, continue with that. Thank you for the attention. If you have questions, don't hesitate to send to me by mail or whatever you prefer. And I'm more than happy to answer. So the topological qubits not functional. Related to topological qubits, it's more a theory than a reality. Even in the case they have sent some message to the market that the topological is closer because they have discovered intermediate technologies that could make easier and feasible the evolution of this family of technologies. This is not a reality today. It's in the lab and in a theoretical environment so far. It's not functional today. Okay. My pleasure. Anyway, Microsoft is the unique company that is investing in topological. In fact, during 2019, they launched a message to the market that they are going to open a research center in Denmark. And suddenly they stop explaining that. So they decided not to open the research center in Denmark. They maintain the infrastructure under their basic headquarters because the success they're expecting on this technology was not so quick that they expected. So I think topological, if they finally appears, will be the winner of every race. But there are more than doubts. Specifically, you talk with physics people, expert physicists, they say that this is not feasible with the current technology we have. So probably we will take a lot of time to see a real topological computer. Okay, thank you very much. If you have any questions, don't hesitate, as I say, to send to mail, and I will try to answer to all of you. If in any case, I hope to see all of you on Thursday at the same time, and probably same link. And probably tomorrow you will see uploaded the sessions and the contents we have seen. Probably not all the slides. I will select, instead of 700 plus, only 700, eliminate some slides that we have not seen detail. In order to not disturb you, you will decide to go in deep on that. So thank you very much, and I will see you on Thursday. Have a nice day or the rest of the day you have. Thank you very much. See you soon. Bye-bye.
Thank you.
Bye. See you.
Thank you. Bye-bye.
Thanks.
Bye. Thanks.
Thank you. Bye-bye.